Hi everyone, it's Miss Costa here, and in this video we're going to go through the most likely topics that are going to come up on the paper 3 for Edexcel Higher on the 10th of June. So like with any predicted paper, I have no clue what's going to come up on the paper. It's just my best guess based on what's come up on the previous two and what's come up in the past years. Now, it's not exactly like a past paper in that I have given more questions and more marks than would be in a normal paper, just because I want you to be as best prepared as you possibly can. So here's a list of the topics. Some of the topics I've done 2 questions for because there's different ways that they can be asked, and hopefully that's helpful. And just a little note to say that this video is made in honour of my dog Shadow, who we sadly lost 2 weeks ago. So I've kind of changed the questions a little bit, reframed them so that they involve his name, just as a little memory for him. He was just the most incredible, ever-loving, pure soul that I've ever known, and I feel so lucky to have had him in my life for as long as I did. Okay, so for the first question we've got standard form. So the first 3 are just simple questions. I'm asked to write a number in standard form. Just remember, to write any number in standard form, you write it as the number times by 10 to the power of something. So essentially I look at the digits and I turn them into a decimal. So 7.65, I know it needs to be times 10 to the power of something. And if you've got a decimal, as in if the number is a really small number, then it's going to be to a negative power. And the quick shortcut way is just count how many zeros there are before your number starts. So there's 1, 2, 3, 4, 5 zeros. So that would be 7.65 times 10 to the power of negative 5. With whole numbers, I'm going to similarly just look at the digits, turn them into a decimal, a 1-digit decimal, so only 1 digit before the decimal point, 5.698 times by 10, and then I count the number of digits that there are before the first digit. So 1, 2, 3, 4, 5, 6, 7 times 10 to the power of 7. Now I've got a number that's been written in standard form and I need to write it as an ordinary number. All that means is just as a number by itself. So 3.678 to the power of, oh, that should say times 10 to the power of negative 4. So to the negative 4 means I'm going to have 4 zeros before my number starts. So 0.000, and then I write my number 3678. And for the next question, I'm told to write 76 times by 10 to the power of 7 in standard form. Now some people might be like, oh, that's in standard form, but it isn't, because this number here needs to be between 1 and 9.9. Okay, so you need to turn this into a decimal, and in order to do that you divide this by 10, and because you've divided one part of the calculation by 10, you're going to need to multiply the other part of the calculation by 10 in order to keep it balanced. So that would be 7.6 times 10 to the power of 8. You can always double check it by actually working out the calculation, and you've got a calculator, so that should be pretty simple. So for this next question, it's a calculator paper, so literally just type in the question into your calculator. Be very careful, especially at the part where after you type in something with a power, make sure you use the arrows to move, to press next, otherwise everything would be done to the power of. Just check that it looks like how your calculation looks like and press equals. You're going to get a number that looks like this. Annoyingly, on this calculator you have to press format and then decimal in order to turn it into a thing. So once I've got that, it gives me the number 712,178.5714, and the question's asking me to give my answer to 3 significant figures. So 3 significant figures, I circle the 3rd digit and then I round, so that would be 712,000, because 1 is less than 5, so it rounds down. Next, I've got an addition. So once again, I could do this on my calculator, so just type in 3.8 times 10 to the power of 4 plus, or I'm going to just do it step by step actually. So 3.8 times 10 to the power of 4 is 38,000, and then 5.8 times 10 squared is 580, and then you add these two together, and the whole point is that you're going to get something that isn't in standard form. So that's 38,580, and then you just convert this back into standard form. So 3.858 times 10 to the power of 1, 2, 3, 4 times 10 to the power 4. So here we've got another slightly tricky one with standard form. The key is use your calculator, let it help you, and just be very careful when you're entering everything. So remember to press the shift button to get the upper things. So like the cubed root, for example, you'd press the shift button and then it allows you to put the cubed root in. So you put the cubed root, then you press your fraction button, and now a cubed, well, a has the value of 3.2 times by 10 to the power 4. So you enter that into your calculator, but you put it in brackets because the whole thing is being cubed. Okay, so the whole thing is being cubed, and then you divide that by 1.8 times 10 to the power of minus 3. Your calculator thankfully works that all out for you, and that would give you 263,062.6213. It says give your answer in standard form, so this is a bit of an ugly number in terms of it doesn't round nicely. So that would be 2.630626213 times by 10 to the power of 1, 2, 3, 4, 5. So remember the power of 10 is thinking about how big your number is. And even though we've got a decimal, the number continues here. So here we've got a best value problem. I'm told that Jenny is going to buy 20 litres of paint, and here's some information about the cost of paint from 2 different shops and which shop should she essentially buy it from. She wants to buy 20 litres of paint as cheaply as possible, so we need to figure out how much it's going to cost in both of the shops. So for prime paint, I know that 2 litres cost £21. And I know that she wants, how much? 20 litres. So if you just set up a little equation like this, you can use the unit method. So you just think to yourself, what do I multiply 2 by to get to 20? I multiply it by 10. So I do exactly the same thing on this side. Therefore, 20 litres is going to cost £210. There's no special offers, so that's just the price she pays for there. Then we can look at paint for less. So I know that a 5 litre pot, the normal price is £65, and I know that there's currently a sale which is 15% off the normal price. So I know that I can get 5 litres, and you can either work out the 15% first, so do 0.85 times 65 and then multiply it by 4, but I'm just going to work out the total cost and then subtract 15%. So no 5 litres is normally £65, and I want to figure out how much 20 litres is. So what do I do? Well, to get from 5 to 20, I multiply by 4, so I have to do the same over here. And 65 times by 4 gives me 260. So the normal cost over here would have been £260, but there's 15% off the normal price. And remember, as a multiplier, if you have 100% and you take 15%, you're left with 85%. And what does percent mean? It means divided by 100. So 85% as a multiplier is 0.85. So to work out like 15% off, just a quick way with the multiplier, we'd just do 260 times by 0.85, which is, times 0.85 is £221. So I would say she should buy from prime paint as it is £11 cheaper. Always, when you've got a question like this, you need to maybe even circle your answers just to show it, just to make it clear to the examiner where they are. £210 versus £221. So here I've got a scatter graph. I'm told that the scatter graph shows the temperature of a park in London and the number of ice creams an ice cream van manages to sell over the summer holidays. First question says that one of the points is an outlier, and I need to write down the coordinates of this point. So an outlier is literally, you're going to get all of your coordinates that roughly follow the same trend. So they're all going in the same kind of direction, they form a pattern. And then the outlier is the odd one out. So the outlier is over here, and let's have a look at what the coordinates is. So if that would be 27, I know that 5 squares make up 1. 1 divided by 5 is 0.2, so each of the little squares is 0.2. So that would be 26.8 as my x coordinate. And then my y coordinate, these bars seem to be going up in, actually, that might even be 26.7. Yeah, sorry, it's very small on my iPad. So 26.7, but you get a tolerance allowance. And then 131. So whenever you've got this, just be really careful with the scales, especially if it seems like an easy question. Just be very careful that whatever the distance is, you divide it by the number of squares, and then that tells you what each square is worth. Now give a reason for why the outlier may have occurred. Okay, so the general trend is that as the temperature rises, the number of ice creams sold rises too. So generally, the hotter it is, the more people go out and the more that they want ice cream to help cool them down. So why might, on a day of 26.7 degrees, which is quite hot, the van have only sold 131 ice creams? Well, I mean, there could have been a lot of reasons, but perhaps there may have been a festival or football on or something that meant people weren't out. So this is kind of like using your real life kind of application. So something that would cause people to not be out and wanting to buy ice creams. Or more likely, the van may have broken down at some point. So perhaps they were selling loads of ice creams and then the machine just stopped working and he had to go home. So anything that would have meant that it's unusual for him to have sold that few ice creams. Next question says, excluding the outlier, what is the relationship between the outside temperature and the number of ice creams sold? Well, as the temperature increases, the number of ice creams sold increases too. So this is a positive correlation. It means as one variable goes up, so does the other. Now the last part, and this is where people always seem to just get a bit lazy and just say, oh, I just know. It says, on one of the days, the ice cream van managed to sell 168 ice creams. Estimate the temperature on this day, and people just go to 168 and roughly say this is where it's going to be, which is great, except you're not going to get any marks for this. So if you see the word estimate, it means you need to draw a line of best fit. You absolutely have to draw a line of best fit. There's no two ways about it. Without a line of best fit, you get no marks, even if you're right. So line of best fit, it doesn't have to go through 0, 0. It literally goes through as many, and that's annoying actually because my pen is really thick, so that's not going to be helpful. Let's try and do it as thinly as possible. Okay, so it wants to roughly have as many points above the line as below, and it needs to be done with a ruler. So to estimate, what we do is we use our straight line. We go to 168. We go up to our line. Then we use that to figure out what the other value is. So that would be, I know that they're going up in 2, so that would be 26.2. And that, okay, so in this question, I'm told that the table shows the weight of 50 Cocker Spaniels. And I need to write down the modal class for the weight of the Cocker Spaniels. So the modal class literally means the class that contains the most amount of values. Remember, the mode is the most common, and modal is just the plural version of the mode. So the modal class, because it's a class, it's not just one value. So you look at the frequency column and you look for the largest value. So 15 is the largest value. Therefore, the modal class is between 9 and 12 kilograms. Then I'm being asked to find the group that contains the median weight. So to work out what the median is, the trick that you use is whatever the frequency is plus 1 divided by 2. And the reason for this, just really quickly, if we have 2 values, let's literally say 3 values. the median is the second value, okay? But if I did 3 divided by 2, because there are 3 numbers, if I did 3 divided by 2, that's 1.5. So it's a little trick that sometimes doesn't make sense to people, but to find the median, you do whatever the total is plus 1, and then you divide it by 2. And that tells you what the median number is. So 51 divided by 2 is going to be 25.5. So I need to find where the 25.5th value would be. So I know the first 3 values are here. 3 plus 8 is 11, so the first 11 values are here. 11 plus 10 is 21, so the first 21 values are here. And then 21 plus 15, well, that's going to give me 36. So I know, once again, that the median is going to be in this class here. So wherever your value lies, all of the values are cumulative when you add them all together, and that's how you find out where the 25th one would be. And then the last thing is to calculate an estimate for the mean. So this is the mean one. This is the one that requires a lot of work. So what you need to do, if it's a grouped frequency table, so this is a grouped frequency table because there are 2 values that it can lie between. And if that is the case, then you're going to just want to draw 2 extra columns for yourself. You don't have to, you can just work out what the midpoint is. But I'm just going to do that just because why not? So if it's a grouped frequency table, you have to find the midpoint. So the midpoint of 0 and 3, how do you find the midpoint? Add the values together and divide by 2. 3 plus 0 is 3, divided by 2 is 1.5. 3 plus 6 is 9, divided by 2 is 4.5. 6 plus 9 is 15, divided by 2 is 7.5. And then we've got 10.5, 13.5, and 16.5. That's the midpoint. And then the last column is going to be your midpoint times by the frequency. So I'm just going to use a calculator for this because it's a calculator paper. 3 times 1.5 is, I should have known that anyway, 4.5. 8 times 4.5 is 36. 10 times 7.5 is 75. 15 times 10.5 is 157.5. 12 times 13.5 is 162. And 2 times 16.5 is 33. So once you've done that, you find the total. Sorry. So to work out the mean from a group frequency table, you do the total of midpoint times frequency divided by the total frequency. So we find out what the total is here. So 33 plus 162 plus 157.5 plus 75 plus, is that 3.6? No, 36 plus 4.5 is 468. And the total frequency is 50. So 468 divided by 50 equals, 9.36. So the mean weight, an estimate for the mean, is 9.36. Okay, so here I've been given, well, I've been asked to draw a frequency polygon for the weights of the Cocker Spaniel. So the same table, just draw a frequency polygon for it. And the key thing with a frequency polygon is always plot against the midpoint. So that's the key thing to know that about a frequency polygon. Also, with a frequency polygon, when you've plotted your points, you join them together with a straight line like this. There's no line of best fit. You join from point to point to point to point. So first things first, I need to think of a suitable scale. So frequency is always going to be your y-axis, and the frequency goes up to 15. So I've got 1, 2, 3 large blocks, so that makes sense to do 5, 10, 15, and 0. Now my x-axis goes up to 18, and I've got 1, 2, 3, 4, 5 large blocks. So 20 divided by 5 is 4. So I could go up in 4s, but I would then want to think about it. If I go up in 4s, then 4 divided by 10 is 0.4. I suppose I could. So either you could go up in 0.4s, or you could just make your scale a little bit smaller and have it 5, 10, 15, 20. Actually, yeah, let's do that just to make it easier. Just because we're plotting against the midpoint. If you did it 0.4, that's absolutely fine. You just have to be a little bit more careful. So over here, we're going to say 5, 10, 15, 20. And I know that because each little gap is 5 divided by 10 is 0.5. So 1 square is half of a puppy. So let's start plotting. So remember, against the midpoint, so that would be 1.5. So 1.5 would be here, 1.5, and then 1, 2, 3. This is a lot easier when you're on paper. So 1.53 would be there. Then we've got 4.5 and 8. So 4.5 would be here, and 8 would be 9, 8. Okay, then we've got 7.5. So 7.5 would be nice and halfway. 7.5 and 10, that's a nice coordinate. Then we'd have 10.5 and 15. So 10.5 and 15. And then we'd have 13.5 and 12. So that would be 12.5, 13.5 would be here, 13.5, and then 12 would be there. And then 16.5 and 2. So 15, 16.5, 16.5, and then 1, 2. Okay, so I've plotted my points. Now I just join them together. I don't start from 0, I start from the first point. With a straight line, I join them boom, 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 in the order that they go. So just be very careful, and if you think you're going to forget, then join them up as you plot them. But that's essentially how you do a frequency polygon. So always a straight line and always plot against the midpoint. Okay, so here you've been given a lot of information, and generally when you're given a lot of information like this, you're going to want to do a two-way table. It doesn't tell you to draw a two-way table. You don't have to do a two-way table, but it helps with organising information. So I'm told that 70 people were asked if they would prefer to have a Cocker Spaniel, a Springer Spaniel, or a Sprocker Spaniel as pet. That is because Cocker Spaniels, any kind of Spaniel, is just the most loving, amazing, incredible pet you could have. So let's have a think. I know 70 people have been asked. I know there are 3 options, a Cocker Spaniel, Springer Spaniel, or a Sprocker. And I know that the people that were asked were children or adults. So I could form a two-way table. There's children and then there's adults, and they had the choices of picking from a Cocker Spaniel, a Springer Spaniel, or a Sprocker. And then with a two-way table, you always just want a total column as well. Sometimes it doesn't work out, so just add it on underneath. So with a two-way table, you can just organise your information so much simpler. So 70 people were asked. You know that your total is going to be 70. You're then told that 28 of the people asked were children, so you know that there's 28 children. And now, with the information that you've been given, you can figure out how many adults there must be. So 70, take away 28, is 42, because the children and the adults must add up to 70. You're then told that 15 of the 23 people who said Springer Spaniel, so where you use Springer, you know there's 23 in total, and that 15 of those were adults. So once again, 15 plus something must add up to 23. So 23 take 15, leaves you with 8. So in pink is all the ones that I'm working out just by elimination. And then in green is all the information that I've been given from the question. 2 children said they would prefer Sprocker Spaniel. So in the children, the Sprocker is 2. And now, if you can see, you've got all of this information here. You know that there is a total of 28 children. 2 of them said Sprocker, 2 of them said Springer. So therefore you can figure out what the last bit is. So 28, take away 8, take away 2 is 18. Obviously you don't need to do this. I just like figuring them all out anyway because it's fun. But you might not actually have needed that information. I haven't even read to the last bit of the question, even though I literally wrote this question a few hours ago. Okay, so next piece is 30 people said that they would prefer to have a Cocker Spaniel. So 30 people, so the total would be 30. And then you can work out any bits of missing information. That must be 12 because 18 plus 12 makes 30. The question says, one of the adults is chosen at random. Okay, what is the probability that this adult said that they would prefer to have a Cocker Spaniel? So one of the adults is chosen at random, so the probability is only going to be out of the total adults, and there's 42 adults in total. And then how many wanted a Cocker Spaniel? 12. So the probability would be 12 out of 42. Okay, next I've got some conversions. So here I'm being asked to change 6,000 centimeters cubed to meters cubed. And remember, when you're dealing with centimeters cubed and meters cubed, just draw yourself 2 little cubes. So 1 meter cubed is where you would have done 1 times 1 times 1, but 1 meter, the equivalent in centimeters is 100. So that would have been 100 times 100 times 100. So 1 meter cubed is actually 1 million centimeters cubed. So to get from centimeters cubed to meters cubed, we divide by 1 million. So I need to change 6,000 centimeters cubed to a meter cubed. So I'm going to divide 6,000 by 1 million. So 6,000 divided by 1 million is 0.006 meters cubed. Then I'm being asked to change a speed of 160 kilometers per hour to meters per second. So step 1, we know that 1 kilometer is 1,000 meters. So 160 kilometers, to go from kilometers to meters, I times by 1,000. So 160 kilometers times by 1,000 is 160,000 meters. So that would be 160,000 meters per hour that is being traveled. But I need to turn this into per second. So in 1 hour, I have 3,600 seconds. So to go from hours to seconds, now this is a little bit confusing because to go from hours to 10 hours to seconds, you multiply by 3,600, but they've traveled 160,000 meters in an hour. So I'm actually going to divide by 3,600. So divide by 3,600 is 44.4 recurring meters per second. So just try and think like logically what is happening. Next question is change 32 millimeters squared to centimeters squared. So once again, just draw yourself a square and think about it. 1 centimeter squared is 1 times 1, but 1 centimeter is equal to 10 millimeters. So 1 centimeter squared is actually 100 millimeters squared. So 32 millimeters squared, what do I do to go from millimeters to centimeters? I divide by 100. So 32 divided by 100 is going to give me 0.32 centimeters squared. And then for the next one, I've just got a calculation. So once again, use your calculator, press the shift and then the little cube root sign, press your fraction button, and then type in 1.34 cubed. Remember to use your arrow to move one across so that you're not having everything as the power, cos 40 over 6.5 to the power of 0.5. And then you would get 0.897505 going on and on it says the 3 significant figures, so we look at the third digit, so that'd be 0.898. So here I've got an exchange rate question. I'm told that in Cardiff, 1 litre of petrol costs 155.18 pence, so £1.55. And in New Orleans, 1 US gallon of petrol costs $3.12. So I'm going to need to either convert my gallons into litres or my litres into gallons, and my pounds into dollars or my dollars into pounds. So I am going to probably stick to gallons. So I know that 1 US gallon is $3.127. Now I know that $1.27 is £1. So if £1 is $1.27, to get from dollars to pounds, I have to divide by 1.27. So I'm just going to divide this by 1.27 to work out what that cost is in pounds. So 3.127 divided by 1.27 gives me £2.46, or 2.46220, blah, 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 blah. But let's round that to £2.46. And that's in New Orleans. So now let's have a look at what's happening in Cardiff. So I know that 1 litre is £1.55, and I want to convert that into 1 gallon. Okay, so what am I going to have to do? I know that 1 gallon is 3.875 litres. So I'm going to have to times both sides by 3.875. So 3.875 times by 1.5518 equals £6.01. So therefore, in New Orleans, 1 US gallon is £2.46, and in Cardiff, 1 gallon is £6.01. So therefore, it is much cheaper in New Orleans, £2.46 versus £6.01 per US gallon. You could have done this and compared the litres, you could have done it compared in dollars. It doesn't matter as long as you've got 2 things that you compare it and you say which one's which. Okay, so here you are told that a square with sides of length x centimetres is inside a circle. Okay, so let's just roughly draw something. That doesn't look very nice. There we go. Inside a circle, each vertex of the square is on the circumference, that's why it's touching it. And I know that the area of the circle is 56. So how do I work out the area of a circle? Area is pi times by radius squared. So I know that 56 is pi times by radius squared. So if I did 56 divided by pi, that would tell me what the radius squared is. And 56 divided by pi is 17.825. That's r squared. So r is going to be the square root of 17.825. I don't need to write it all out. I can just type in the square root of answer on my calculator. Therefore, I know that the radius is 4.222008246. So I know that the radius is 4.22. So here is my radius, and let's think about what I can do. So I could create a diameter going from one edge of the circle to the other that also is the corners of the square. So therefore I have worked out what the diameter is, and the diameter is the diagonal of the square. So if I times the radius by 2, because the diameter is 2 times the radius, because if you think about it, that is your radius and that is also a radius, so 2 lots of it make your diameter. So the diameter is times by 2, 8.44016,491. Now, here is where I need to just do a little bit of kind of problem solving and thinking. So what do I know? I need to figure out what x is. So I could imagine that this is a triangle with a hypotenuse of 8.44. I missed out a 4 there. And it's a square, so the sides are all equal. So if this is x, this is also going to be x, and I can use Pythagoras. So I know that x squared plus x squared must equal 8.44 squared. Sorry, I don't know. I've got a bit of a cold and my voice goes sometimes. So because they are both the same, they're both x squared, and I can collect the like terms. So I know that 2x squared must be 8.44 squared. I could then divide by 2. So x squared is going to be 8.44 squared divided by 2. So let's actually just type that out on my calculator. So 8.44, or my answer, squared divided by 2 is 35.6507. And to figure out what x is, I'm going to do the square root of that, and I just type in my square root of answer. So square root of answer is 5.9708 to blah blah blah, but it says give your answer to 3 significant figures, so x is going to be 5.97, and that would be what the side length of the square is. Okay, so in this question, I am told that a parcel in the shape of a cylinder is placed on a horizontal floor. So you could just visualize what's happening. So it's a parcel in the shape of a cylinder. The parcel exerts a force of 150 newtons on the floor and a pressure of 30 newtons per meter squared. The face in contact with the floor is a circle, so over here, with diameter x centimeters. And I need to work out the value of x. So let's first start by using the formula. I know that pressure is force over area. I've been given the pressure, I've been given the force. So actually what I want to work out is the area. So I can just rearrange it. And whenever you have like the subject and what you want to be the subject as a denominator, you can just switch them. So area is therefore force divided by pressure. So I can figure out what the area of the circle is. So the force is 150 and the pressure is 30. 150 divided by 30 is 5 meters squared. Now once again, what's the formula for the area of a circle? It's pi times radius squared. So I know that 5 is equal to pi times by radius squared. So if I just rearrange that, 5 over pi is the radius squared. And let's type that into a calculator. So 5 divided by pi is 1.591 is the radius squared. So the radius is going to be the square root of that. So square root of answer is, or 1.2615. And I've been asked to work out the diameter. So the diameter is going to be twice the radius, so times that by 2, which is 2.5231325 blah 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 meters. Now the question says give your answer to the nearest centimeter. So because I'm now working with linear measurements like length, not area or volume, I know that 1 meter is 100 centimeters. So 2.523 meters is going to be, just times it by 100, 252.313 centimeters, and it says to the nearest centimeter, so that would be 252 centimeters. Okay, so here I've got a box plot that shows information about the sales in thousands of pounds of Pet Shop A each month. Valentina says 1/4 of the given data lies between £150,000, which is here, and £400,000, because these are the values of the lower quartile and the upper quartile. Okay, so yes, she is correct. That is the lower quartile and this is the upper quartile. However, because of that, it means she's actually incorrect. So this is always going to be your lowest value, the little whisker of the diagram, and this is your max value. Then the lower quartile and the upper quartile are here, and this is your median. So essentially your data is split into 4 parts. First quarter is here. Second quarter is here. So between the lower quartile and the median. Next quarter is here, and the next quarter is here. So actually, no, she is not correct. 50% of the data lies between the lower quartile and the upper quartile. You could also have said a half of the data if you wanted to keep it in fractions, but essentially each little quartile is a quarter of the data. And so this middle bit here is the middle 50%, and it's called the interquartile range, and it's really useful because it tells us what's happening for the middle 50% of the data. Okay, so now I need to draw a box plot, and remember you've got every single box plot is going to look something like this, where this little part is your lowest value. This is going to be your lower quartile. This is going to be your median, then your upper quartile, and your maximum value. And this middle piece of data over here, so the interquartile range, what's happened there, is the upper quartile, take the lower quartile, and it tells you like the middle 50% of the data, and your total range is going to be your max value, take away your lowest value. So let's have a look at what I've been given. I know the least number is 120. So the distance between these 10 squares is 100, so each square must be worth 10. So 120 would be here. The lower quartile is 180. The median is 200. The upper quartile is 250. And the range, okay, so I haven't been given the maximum value, but I've been given the range. And how do I work out the range? It's the max value take away the lowest value. So I know that the lowest value, which is 120, plus the range, 230. So 120 plus 230 is 350. And that tells me what the maximum value is. So I can complete my box plot like that. And that's how I'd do that. You don't need to label them saying lower quartile and upper quartile and everything else, but just be mindful of the scale and double check it. Is the total range 230? Well, 350 take 120 is 230. So yep. Okay, so here I'm being asked to compare the distribution of the sales of shop A and shop B. Now, in order to do this, there are 2 things that you always want to compare when comparing distributions, and that is the median and either the range or the interquartile range. Because the median tells you the overall performance, and the range or the interquartile range tells you the distribution, so the spread of data, so how close together all the values are and how consistent they are. So first of all, let's see what the median is. So the median of shop A is 250,000 and the median of shop B is 200,000. So the median of shop A is higher than shop B, suggesting that overall shop A has higher sales. So the higher the median, the higher like the overall. We use the median to say what's happening overall. And then you could put your values, but just be very careful. So 250 versus 200, because if you put the wrong values, you actually can't get the mark. So if you're going to put the values, make sure they're the right ones. So that's the first thing. And secondly, we either compare the range or the interquartile range. The interquartile range is generally a little bit more accurate. So let's do that. So over here, that is 150 and that is 400. So the interquartile range of A is 400 take away 150, which is 250,000. And shop B, we worked out, well, we're going to have to work out again. So 250 is the upper quartile, take 180, which is the lower quartile, which is 70,000. So basically, the larger the range, the more inconsistent the data. So like one day you might be getting this, one day you might be getting that. So if you look at the box plot we drew for shop B, you can see that the middle 50% of the data is really clumped together, whereas here it's actually quite spread apart. So the interquartile range of shop B is a lot less, suggesting that the sales are a lot more consistent in shop B. So the spread of data is a lot smaller. The sale prices have a smaller range. And that's what we do to compare distributions, so median and either range or interquartile range. Okay, so polygons question, and polygons are super fun. So let's see what's happening. So I'm told that the diagram shows a regular pentagon. Regular is a key word because it tells me that it has equal sides and all equal angles. So that's really important because it means I can work things out. And two identical squares that are balanced to form a triangle. Sorry, my voice is just going. The side of square A that touches the top vertex of the pentagon over here is on the line of symmetry of the pentagon. So what that means is it splits the pentagon exactly in half. And I need to work out the value of x. Okay, so first of all, what I want to do is figure out what the angles in the pentagon are. You may already know this, but if you didn't, whatever the size of the polygon is, you just think to yourself, how many triangles can I fit in there? And you do that by putting a point on one vertex, one corner, and then you draw straight lines to each other vertex. So obviously that line just draws on top of an already existing line. Then I draw another line over here, another line over here to this one, and another line over here. So in total, how many angles are there in there? That's three triangles in there. And what do I know about triangles? I know that their angles sum to 180. So each of these little angles are going to sum to 180 each, and I've got 3 of them. So I do 3 times 180, which gives me 540. And this is the rule for any pentagon. However many sides there are, you take 2, because that tells you how many triangles there are. Okay, and this will work for absolutely anything if you use the rule I just told you. Start from one vertex and join them. So in this case, there's 3 triangles. I times it by 180, and I know that 540 is the total angles. Now, I've been told it's a regular pentagon, which means all angles are equal. So therefore, if all angles are equal, and there are 5 of them, all I need to do to work out one is 540 divided by 5, which is 108 degrees. So I know this angle here is 108 degrees. Now, what can I do? Okay, so I've been told that these are identical squares, which means this side and this side must be equal. So therefore I have formed an isosceles triangle over here. So that will probably be important. I know that this angle here is 90 degrees. And I also know that this is a line of symmetry here. So therefore, half of this angle, half of 108, is 54 degrees. So I could use that to figure out what this angle here is, because this is a straight line. So if you just visualized it like that, 54 degrees here, and 180, take 54 is 126. So I know that this angle here is 126. This angle, it's a square, so I know it's 90 degrees. And if I've worked that out, I can figure out what this angle inside the triangle must be, because angles at a point sum to 360. So I could either do well, you can do whatever you want. You could do 360, take away all of those angles, or you could do 180, take away 54, take 90, because these two angles here are on that. So I'm going to do that. 180, take 90, take 54 is 36 degrees. So I know this little angle there. Let's just draw that triangle a little bit bigger. So, this triangle here has an angle here that is 36 degrees, and it's an isosceles triangle, which means its base angles are equal. So this angle here is going to be 36 degrees, and I can use that to figure out what this angle here must be, because angles in a triangle sum to 180. So 180, take away 36, take 36 is 108 degrees. So I know that this angle here must be 108 degrees. These are my squares, so I know these two angles are 90. And once again, I've got angles at a point. So you could visualize it like that. So to work out what angle X is, you just do 360, take 108, take 180, because two lots of 90. So 360, take 108, take 180 gives me 72 degrees. So X is 72 degrees. Now it hasn't told you to give reasons, but if it did, then you would have just written down the reasons that I was saying. So like angles at a point, angles in a straight line, it's an isosceles triangle because the sides are equal and all of those things. Okay, so here we've got a question where we're dealing with a negative scale factor and a fractional scale factor, although it's written as a decimal. So the difference between a negative and a normal scale factor, first let's plot the center of enlargement and it will make more sense. So the center of enlargement is 5, 6. So 5, 6 is over here. Now, if you're just ordinarily like multiplying, enlarging something by, let's say, scale factor 2, what you would do is you would count the squares from the center of enlargement to your shape. So let's just say that's 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. Let's say we're enlarging it by scale factor 2. What you would do is you'd double those distances. So it would be 14 and 6, and then you'd plot your new point. So for normal enlargements, you go from the center of enlargement to your shape. But with a negative enlargement, it reverses the direction, and you actually start from the shape and then go towards the center of enlargement. So let's try that. So this is my first coordinate. I want to see how many squares I go across and up. So I go 1, 2, 3, 4, 5, 6, 7 squares across, and then 2 up. And what I need to do is I need to multiply that by 0.5. So that would be 3.5 across and 1 up. So from the center of enlargement, that's what I do. 3.5. So 1, 2, 3.5, and then 1 up. That is where that coordinate would be. Let's try it with the next coordinate. So that's the next vertice. So how many do I go across? I go 1, 2, 3 across, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squares up. So once again, times that by 0.5. So I'd go 1.5 across and 5.5 up. So from the center of enlargement, I go 1.5 across and then 1, 2, 3, 4, 5.5 up. So that would be there. Oh, and that was a circle. And then let's do it with the final vertice. Let's just do that as a square. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 across in order to get to your center of enlargement. And then you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up, which is obvious because the other corner is also there. So I'd be going 5.5 across and 5.5 up from the center of enlargement. So here's my center of enlargement. I go 1, 2, 3, 4, 5.5 across, and then 1, 2, 3, 4, 5.5 up. So that is where that would be. And then you just join them together like that. So in the exam, it's not going to be like as annoying, hopefully. But essentially, when you have a negative scale factor, it flips the what's it called? The shape on its side. There are other ways that you can do it, which is using like the line method, but this is the method that I prefer. Okay, so we're dealing with compound interest. So Shadow invests £35,000 in an account paying compound interest for 5 years. And all compound interest means is that essentially whatever you have made on interest at the end of the year, that gets reinvested. So you're actually earning interest on all of the money that you've earned, including the free money you've got from the interest. So it's a really great way of growing your money if you can find an account with a good interest rate. So in the first and second year, the interest rate is X%. I don't know what it is, but I know that at the end of the second year, the investment is £40,825. So 35,000 times by, and let's say that the multiplier is Y, because I don't want to get confused with X. So Y times by Y is 40,824, because whatever the interest rate is, the multiplier, that would be entailed in Y. So the multiplier, let's say the interest rate was 3%, the multiplier would be 1.03. So X is 3%. I'm not calling it X because it might get a bit confusing. So I'm just calling the whole multiplier Y. And that will be easier to work out the interest rate. So I know that 35,000 times by Y squared is 40,824. So Y squared must be 40,824 divided by 35,000. So let's type that into my calculator. 40,824 divided by 35,000 is 1.1664. So therefore Y is going to be the square root of that. And the square root of answer is 1.08. So I know that my multiplier is 1.08, which must mean that the interest rate, X, is 8%. Okay, so that's why I didn't want to get confused between the multiplier and the interest rate. That's why I called it Y. So I know that the interest rate for the first 2 years was 8%. It then says in the final 3 years, the interest rate is X over 2%. What is the value of the interest that he has earned by the end of the 5 years? So if the interest rate was originally 8%, X divided by 2 is 4%. So at the end of the second year, he's got £4,824, and that's invested for year 3, year 4, and year 5. So I'm going to times it by 1.04, times by 1.04, times by 1.04, which you could obviously write as 1.04 cubed, but just to show you how you break it up in the years. And that would give me 40,824 times by 1.04 cubed is £45,921.45. I've just rounded it. But read the question carefully. It says, what is the value of the interest that Shadow has earned by the end of the 5 years? So if he invested £35,000, then we're just going to subtract that. So 45,921, take away 35,000, and my answer is saved, so I'm not just entering that, I'm just writing it so that I'm not wasting time, even though I just wasted time telling you. Anyway, answer, take away 35,000, gives me £10,921.45. And that is an excellent interest rate if you can ever find any bank account giving you 8%. Easy way to make great money. So in this first question, I'm just being asked to expand and simplify. So that's what I do. I multiply everything. Remember, when you're multiplying surds, you can treat it like algebra. So you could imagine that's the same as saying 3 times 2x, which would be 6x. So that would be 6 root 2. 3 times 4 is 12. And then minus 8 times 4 root 2. Again, imagine it is algebra. So minus 8 times 4x would give you minus 32x, but it's root 2 instead. And then minus 8 times by minus 5 is going to be plus 40. And then you add on 3 root 2. So because you can treat it like algebra, if you were to say 6x plus 12 minus 32x plus 40 plus 3x, how would you simplify that? Well, 12 plus 40 is 52. And then you've got minus 32x plus 3x plus 6x. So minus 32x plus 9x, which is going to be minus 21x. I think my brain is very tired, so let's just double check. 32 take away 9, it's 23. That's why it's important to double check. So 52 minus 23x, except this is not algebra, it's surds. So instead of the x, you just write 52 minus 23 root 2. I just showed you the algebra way just to show that if you panic in the exam, turn it into algebra and then the same rules apply. So that would be 52 take 23 root 2. Next, we've got this nice little algebraic fraction. So what you can do is think to yourself, that's the same as saying 13 times by x minus 3 times by x minus 3 times by x minus 3 over x minus 3 times by x minus 3. If you can't see it automatically, just split it up into its basic algebra. And then you know that if you've got a fraction and the numerator and the denominator are both products, so there's no like in between terms, everything is being multiplied, then anything that's on the top and the bottom cancels out, because like 5 divided by 5 is 1. So therefore x minus 3 over x minus 3 is also going to be 1. So that cancels with that, gives me 1. That cancels with that. And at the bottom, you're just left with 1. So that would be 13 x minus 3 over 1, which is just 13 x minus 3. And you can leave it like that because generally being factorized is its simplest form. Okay, for the next part, we've got this algebraic expression to the power of negative 3 over 2. So when it's a negative, either you figure out what it is and at the end you just switch it over. So basically, if you see a negative, it means it's reciprocal. So like, for instance, 8 to the power of minus a half or minus a third, that would be 1 over 8 to the power of a third, which is 1 over the cubed root of 8, which is 1 over 2. So if you had worked out 8 to the power of a third, which is 2, at the end, instead of doing this, you could have just flipped it. So that's the method we're going to try now. We're just going to ignore the negative for now, but know that at the end, I'm going to need to do its reciprocal, which is flipping it. So I've got 4x to the power of 4, y squared, to the power of 3 over 2. Now with fractional indices, remember that this is the denominator tells you what root it is, and the numerator tells you what power it is too. So each of these things are being rooted. So we've got the square root of 4 times by the square root of, okay, so basically, I think the easier way, yeah, so let's just do it all in one go. So split everything up, remember that it's being multiplied. So you'd have the square root of 4 to the power of 3 times by x to the power of 4 to the power of 3 over 2 times by y squared to the power of 3 over 2. So we can do these all one by one. So that square root of 4 is 2, and 2 cubed is 8. And then x to the power of 4 times by 3 over 2, that would become 12 over 2, which is 6. So that would become x to the power of 6. And then y squared is being times by 3 over 2. So multiply the fractions, because remember in brackets, the law of brackets is you multiply the indices. So 2 times 3 is 6, divided by 2 is 3. Okay, so that is what that would be, but it's the reciprocal. So all I do is, the final step is 1 over 8x to the power of 6 y cubed. Okay, so here I've been given a trapezium and its lengths have been given in surd form. So let's just recap on the area of a trapezium. The area is a plus b times by the height divided by 2. And remember that a and b, they are the two parallel sides. So you can generally identify them. Actually, this should have a little thing. They will be kind of obvious because they would have the little parallel lines, and this should have done. So the two parallel sides, and then you times it by the height. The height is always the vertical height, so the perpendicular height. So if you're ever given the slant height and the vertical height, sometimes they do that just to confuse you. Always know that it's the perpendicular height, which means it meets at right angles to the base. So like that and that meet at right angles. So you know that's the square root of 3. So let's do that. So a plus b. So this is a and this is b. It doesn't matter which one's which because you're just adding them. So 2 plus root 3 plus 4 plus root 3 is then going to be times by root 3, and then I'm going to divide everything by 2. So let's simplify that. 2 plus 4 is 6, and root 3 plus root 3, remember you can treat it like algebra, x plus x is 2x, so that would be 2 root 3. And this is then going to be times by root 3, and then I'm dividing everything by 2. So root 3, let's put it like a bracket like that. Root 3 times by 6 is just going to be 6 root 3. And root 3 times by, this is where it's a little, hopefully you remember that a surd times by itself is its unsurded self. So root 3 times by 2 root 3, that's the same as saying 2 times root 3 times by root 3. So this is just going to become 3. So that's the same as saying 2 times 3, which is 6. So I'm left with 6 root 3 plus 6 over 2. And all I need to do is divide everything by 2. So 6 root 3 divided by 2 is going to give me 3 root 3. And 6 divided by 2 is 3. And you've got that in the form a root 3 plus a, where a is 3. Okay, so a pet shop has 5 Cocker Spaniel puppies, 7 Ragdoll kittens, 9 Scottish Bluefold kittens, and Jada is going to choose one of the following combinations for her new pets. So she's either going to choose a Cocker Spaniel puppy and a Ragdoll kitten, so either one of the 5 Cocker Spaniels and one of the Ragdoll kittens, so in total that would be 35 combinations. Or she's going to choose a Cocker Spaniel and a Scottish Bluefold, so that would be 5 times 9, which is 45. Or she's going to choose a Cocker Spaniel puppy, there's 5 of them, a Ragdoll kitten, 7, and a Scottish Bluefold kitten, 9. So 35 times by 9 is 315. Show that there are 395 ways. Well, if I just said 315 plus 45 plus 35 equals, hopefully, 395. So remember the rules with probability. If it's something and something happening, you multiply. And if it's something or something, then you add. So the and rule is you multiply, the or rule is you add them. And that's why over here when I'm looking at my combinations, I'm multiplying because I have 5 little puppies, 1, 2, 3, 4, 5, and each of these could be paired with any of the 7 kittens. And so that's why I do 5 times 7, and similarly 5 times 9, and so forth. So yeah, that's how I do my combinations. So another slightly unrealistic thing, because Even if a dog did have a safe, I don't think they'd have the dexterity to open it with their large paws. But this actually happened to me when I was traveling. And it took me a very, very, very long time to open my backpack that had a lock on it. So Shadow forgets the combination for his puppy safe. There are 4 digits, okay, so there are 4 digits on the safe, and they use the numbers 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm writing these out because the amount of people that get questions like this wrong because they think there's only 9 options. If it's the number 0 to 9, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 options. So there are 4 digits that use the number 0 to 9. He remembers that one of the digits is a prime number. Okay, so what are the prime numbers? Remember, prime numbers are 2, 3, 5, 7, 11. So 2, 3, 5, or 7. So that's 4 options that one of the digits could have. And that the other is a square number. So what are the square numbers? 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so forth. So that would be 1, 4, and 9. That's 3 options. And for the others, I'm going to have 10 options, okay, because it could be any of those numbers. And obviously this number could be here, this number could be there, but it doesn't matter because it's just the amount of combinations I'm looking at. So the total number of combinations for the safe are 4 times 3 times 10 times 10. So 4 times 3 times 10 times 10 is 1,200 combinations. And yes, my fingers and thumb were very, very sore after that. And yes, it was 9999, which I obviously should have tried first. It was a big mistake that you learn from. So what's the maximum number of combinations Shadow will have to try before he can unlock his puppy safe? Well, the maximum number would be 1,200 if he is unlucky, like I was, and it's the last possible option. Okay, so here we've got a few rearranging formula because it can come up in so many different ways. So rearrange to make X the subject. The first thing you want to do, if something is affecting every part of one side of the equation, then that is what you want to get rid of. So the whole of this fraction is being cube rooted. So the first step is to cube both sides. So y cubed would be equal to x to the power 4 plus 3 over 7. Then we've got it into a nice little fraction and we can just do what we normally do. Because x is stuck up here, we can't do anything, we can't move anything up here. If something's in a fraction, you have to first eliminate the denominator before you can touch anything on the numerator. So everything is being divided by 7, so we times both sides by 7. So that would be 7y cubed equals x to the power 4 plus 3. Then what do? We take 3, so that would be 7y cubed take 3 equals x to the power 4. And then the final part is you're going to want to do the root 4 7y cubed take 3 is going to give you x. So you're always, just to move anything from one side of the equation to the other, you just do the inverse. Over here we've got another subject of the formula. So you've got 2 terms that have x in it. So what you want to do, if you've got 2 terms that have x in it, bring them both to the same side, and then you're going to want to factorize. So let's move everything around. So you've got 8x minus pi x. I'm going to take pi x from both sides, and at the same time I'm then going to add 7 just to make it a little bit quicker. So that would equal 4y plus 7. You could have done it in 2 steps if you prefer. So now I've got both of my x terms on one side. What I can do is factorize it so that I just get x on its own. And then if I factorize that, I just have one lot of x, and I can divide both sides by whatever's in my bracket. So if you divide both sides by 8 take pi, you're left with x equals 4y plus 7 over 8 take away pi. And there you've rearranged it. Okay, so another rearranging. So I've got x as my denominator. So the first thing I want to do is multiply both sides by x to get rid of that as a denominator. The next thing I can do is expand my brackets. So yx equals 8a minus 16x. And remember that when you've got two terms that contain the thing you want to make the subject, you want to put them on the same side because then you can factorize them. So I'm going to bring over 16x equals 8a. And then I've got two terms with x in it, so I can factorize the x out. So that would be xy plus 16 equals 8a. And therefore, the final step would be to just divide both sides by the bracket. So 8a is y plus 16. So let's try that with a slightly harder one. Same principle though. So times both sides by the denominator, because that's what you want to do so that you don't have a fraction. So y multiplied by x minus 2 equals 4x plus 3. We're going to have to expand this because x is the term that we want. So yx minus 2y equals 4x plus 3. Remember that you're going to want both of your x's on one side. And I'm going to move the y over here because otherwise everything's going to be negative. Remember, you can play around with things, moving them from one side to the other as much as you want. It doesn't matter as long as you're doing the inverse operation. So yx equals 4x plus 3 plus 2y. Then if I subtract 4x, I'm left with yx minus 4x equals 2y plus 3. Now I can get to the point of factorising. So x is going to be y take 4. So all I've done is I've factorised x out of it. So that is over here. And then the final step, just divide by the bracket. So the key thing here is everyone seems to find these things a little bit tricky, but all you want to do is when you've got a complicated thing like this is jiggle things around, move things from one side to the other. Eventually you're going to get two terms that have x or y or whatever it is that you want to make the subject. You just bring them together on the same side, factorize it, and then divide both sides by the bracket, and then it's your subject. Okay, so here we've got quite a tricky question involving bearings. So the first few things that we need to really bear in mind when dealing with bearings is that we always start from due north. So all bearings, you're always going to see this little due north sign. And we always start measuring it from north so that when we're communicating with bearings, we know like in what relation it is to. So always start from due north. You always go clockwise. You always write them as 3 digits. So if the angle you found was, let's say, 52 degrees, you would write that as 0,352. And the last thing is that you always start from where it says from. So these are the key things that we need to know. If bearings are a little bit confusing, then just watch the full video that I've done on bearings where I explain through it a little bit more slowly. Now, sometimes it's not just going to be bearings you're going to need to use, it's going to be trigonometry as well. And if it's something that looks like this, likely that's going to be the case. So the cool thing about bearings is that they are always, like I said, you always start from due north. So let's just imagine it's a simple bearing where you've got a ship here and a port here. Now what we do is we have our two bearings, like literally this point here is where the ship is, this point here is where P is. And what we can do is draw a bearing going up north. So draw our little up north sign and just draw a line connecting the two bearings. Now, if I wanted to work out the bearing of the ship from the port, what I do is I start from due north, I go clockwise until the line, and this would be the bearing. So let's just say that's, I don't know, 280 degrees. So the bearing of the ship from the port would be 280. However, if I wanted to work out the bearing of the port from the ship, then I'd start from here and I'd go clockwise. So it would be this bearing here. So that's just something to bear in mind. But let's apply it to this question here. So I've got 3 towns, Branton, Cordon and Dorringford. And I know that Branton is 7 kilometres from Cordon on a bearing of 41 degrees. And that Cordon is 9.5 kilometres away from Dorringford on a bearing of 160 degrees. So that's all the information that I know. Now, using bearings is always going to be really helpful if you just use your knowledge of parallel lines first, especially if you don't know where to start. So over here, I've got my due north sign. Over here, I've got another due north sign. Therefore, these two lines are parallel because they are both just straight up north. So using parallel lines, I know that when angles are on the inside of the parallel lines, they are called co-interior angles, and they sum to 180 degrees. So therefore, I can figure out what this angle here is by doing 180, take away 41, which is 139 degrees. So I've figured out just that little bit of angle there. When you get a complicated question like this, you're always just going to want to problem find like a little hunt for anything that you can get. You don't, well, I never start where it's asking me to. I always think, what can I figure out from the question already? What else can I do? Well, I know that this over here is a point, and I know that angles are points sum to 360. So I could figure out what that angle there is by doing 360, take 139, take 160, which leaves me with 61 degrees. So these are just the easy angles that I can find out before I've even looked at the rest of the question. Now, I want to find the bearing of Dorringford from Branton. Now remember, that's the key word that we need to look out for. So we start from where it says from. So first things first is I want to draw a straight line from bearing, what was it called, Branton to Dorringford. So essentially, I'm just going to get rid of all of this. Essentially what is happening is this is the bearing that I need to work out. So I'll just draw it separately here. So this is Branton, and this is Dorringford. Okay, and this is what it would look like if it was just one bearing. And I need to work out this angle here, which would be all of this. So in order to do that, I have formed a triangle here, and I know this angle here is 61 degrees because it's over here. I know this side here is 7 and this side here is 9.5. So I am going to have to use some advanced trigonometry to help me work the next steps out. So I've got two sides, one angle, and the trick is when you're using the sine rule, you want to have two sides and their corresponding angles, one of which you want to find out. But essentially you want two sides and two angles, and one of them can be missing, but it needs to be corresponding. Whereas here, if I just labeled this triangle, let's label this big A and this little a, and this would be little b. So this here would be big B, this C, and this would be big C. I don't have the corresponding angles for anything apart from A. So if you only have one angle and its corresponding side, then you're most likely going to use the cosine rule. So the cosine rule is a squared equals b squared plus c squared minus 2bc cos A. It's also on your formula sheet though, so you don't need to worry about memorizing it. And all this means is a little letter, it represents a side, and a big letter, it represents an angle. And you can label your triangle however you want. A, B, and C, if they've labelled the triangle A, B, and C, but you want a different angle to be A, that's absolutely fine. Cross out what they've written and you relabel it the way you want to. So I know that B is 9.5, C is 7, and big A is 61. So to work out the length of this side here, which is what my bearing of BD is on, I would do 9.5 squared plus 7 squared, take away 2 times by 7 times by 9.5 times by cos 61. So A squared is going to be, and I always tend to do the calculation in two parts, so I do 9.5 squared plus 7 squared, just because it minimises accidental errors on the calculator. So that's 139.25, and then 2 times 7 times 9.5 times cos 61 is 64.47 96, but I don't need to write it all out because it's memorized on my calculator. So a squared is going to be 139.25. Oops, I'm supposed to be typing that into my calculator. 139.25, take away answer. So your calculator automatically memorizes the last thing that is that it calculated, so you can just use that as a shortcut. So take away answer is 74.7703 blah 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 blah, and a is going to be the square root of this. So a is square root of answer, which is 8.646. So I'll just rub this out so that there's room for it. Actually, I'm going to write it out here just in case I need the full for later. So 8.646983318. Okay, so this is the length of this side here. Now, once again, I've got the same triangle, and the thing is, because it's a tricky question, and a question similar to this appeared as like the last question on one of the papers, so this is not an easy question, but I just wanted to throw it in there because it's important. So let's have a look at what we know now. We know that this is 61. We know this is 8.64. We know that this is 9.5 and that this is 7. And this here, this angle here, is the angle that I'm after, because if I know what that is, I can work out what the bearing is. So let's label it again. We can keep this as it was. I can't remember if this was little b or big B, but it doesn't matter. So, and with the sine rule, there are two options. You can either write a over sine A equals b over sine B, or it can be sine A over A equals sine B over B. Now this option, and once again these are on your formula sheet, is best if you are finding a side, and this option is best if you are finding an angle. And the reason for that is because you essentially want whatever you're finding to be the numerator of the fraction, because then it's less rearranging, but on it, you can actually use either. It's just a bit more rearranging, but it's just a helpful hint to know. So I'm trying to work out the angle, so I'm going to use the second version where the angle is on top. So sine A over A is equal to, I'm supposed to be substitute, so sine 61 over 8.64 is equal to sine B, which I don't know, it's this here, over 9.5. So therefore, if I multiply both sides by 9.5, sine B is going to be equal to, so sine 61 over 8.64 times by 9.5 is 0.96167, and so forth. Remember, I'm going to save this as my answer, so I don't need to write everything down. So therefore, the value of angle B is going to be the inverse. So I press shift, sine, and then answer. So shift, sine, answer, and that tells me that angle B is 74.0865, so forth, degrees. So I need to work out this bearing of Dorringford from Branton, strange names. So therefore it's going to be this angle here. Remember, you start from due north, you go clockwise until you reach the line, and your bearing is going to have to be 3 digits. So 74.0865 plus 41 is 115. 0.086506, that's the angle. Now it's saying give your bearing to 1 decimal place, which I will do just now. So I know that this angle here is 115.086506, so therefore the bearing to 1 decimal place is going to be 115.1 degrees. And yes, a slightly tricky one, but basically if you have something that looks complicated and looks like you could form a triangle, you're going to use the sine and the cosine rule. So just see what you can substitute, see what you can figure out, and you will get somewhere. Yes. Okay, so Willow wants to work out an estimate for the total number of hummingbirds in a nature reserve. Now this is the capture-recapture method, and essentially it's saying that if you catch, so let's say on day 1, you catch the number, however many you catch on day 1, over the total population is going to be an equivalent fraction to if you then on another day go out and, so basically with capture-recapture, you capture a certain amount of, in this case, hummingbirds. So let's say on the first, well, actually, let's do it. So on Saturday, she catches 35 hummingbirds, okay, marks each of them, and then releases them back into the wild. So the idea is that these 35 birds are representative of the whole population. So 35 over the total population, to estimate the population, I make it equal to what I then capture on my second day. So the idea is that on the next day, you catch a certain amount. So in this case, she catches 72 hummingbirds. That's the total. And 6 of these are tagged. So the idea is that the proportion of tagged to untagged is going to be equal to the proportion of the ones she caught out of the total population. So that's how we use the capture-recapture method. And in order to work out the total population, we can just call that x and then just rearrange everything. So in order to, so if you were just solving this like in an equation, what would you do? You times both sides by x. So 35 would be equal to x times by 6 over 72. And then to get x on its own, what would you do? You divide both sides by 6 over 72. So therefore 35 divided by 6 over 72 equals x. And 35 divided by 6 over 72 is 420. So that would be an estimate. Another way you could do it is you could have said 35 over x equals 6 over 72. So you could have thought to yourself, okay, what's 35 divided by 6? That is 5.83 recurring. So 35, so 6 times by 5.83 recurring gives me 35. So therefore, if I multiply 72 by 5.83 recurring, that would give me x. So it depends which method you prefer, but essentially you write the amount you catch on the first day over the total population is equal to the fraction of the ones that are tagged over the total ones you catch on the second day. Okay, so now a nice circle theorem. So I'm told that B, D, E and F are 4 points on a circle, and the ABC is a tangent to the circle. So automatically I should be either thinking tangent and a radius, which doesn't apply here because there is no radius, or tangent and a chord. What do I know about a tangent and a chord? That is where I have the alternate segment theorem, and that states that essentially if you have a tangent and it intersects a chord, then the angle formed, so this angle here between the tangent and the chord, so in this case this angle here, the angle formed between the tangent and the chord is going to be equal to the angle in the alternate segment. So if you look at the chord, this is the segment the first angle is in, so this whole thing is going to be the alternate segment. But some people find that confusing. So if you just think about it as this is the chord, okay, so this angle and this angle are touching the chord, so they cannot be the alternate segment, then the only angle that is left is this one over here. So that's the alternate segment theorem. So that should spring to mind. And then what else? Well, sneaky, this is sometimes sneaky because people just find it hard to visualize, but that's why it's good to have a highlighter and just literally go around and see what shapes you can make out. This is a cyclic quadrilateral, and you know that cyclic quadrilateral, in a cyclic quadrilateral, and that is when all of the vertices are touching the circumference of the circle, which this one is, opposite angles sum to 180. So these are the two circle theorems that are screaming out at me initially. So let's see if they apply. So angle DBE is 25 degrees, great. The sines of angle BDE, so this angle here, to BFE, this angle here. Okay, so what is good about this is that already I can see that these, if I think about it as a quadrilateral, so remember that you can think about the whole thing as a quadrilateral, I know that these two angles must sum to make 180. So let's try that again. So BDE is 3 parts. So let's just call that 3x to 2x, just so that I have something. It's in the ratio 3 to 2, so whatever the angle is, I can call that. I don't know why I'm struggling to explain why you turn it into 3x. So what a ratio 3 to 2 means is that for every 3 parts, or let's say degrees, for every 3 degrees that this angle has, the other angle has 2 degrees. So whatever the degrees is, 3 lots of x is this angle, and this angle is 2x. And the reason I do that is because I can then form an equation. So 3x plus 2x must equal 180. And the reason would be cyclic quadrilateral sums to 180. So 5x equals 180. So therefore x equals 180 divided by 5, which is 36 degrees. Therefore, 3 times 36 is 108. So this angle here, oh, why does it do that? So this angle here is 108 degrees, and then 2 times 36 is 72. So this angle here is 72 degrees. Okay. Now, there are, sorry, there are a few ways that we can go about the next part. So one of them is using the alternate segment theorem. So there's actually just so many ways that we can do this, but let's have a look at this. So this is a chord, and this little angle here must be equal to this little angle here, and I could go about that way if I wanted to. Yeah, why not? Let's go about that way. So if I just took this triangle out, I know that this is 25 degrees, this is 108 degrees, so I could work out what this is by just doing 180, take 108, take 25 equals 47. And I'd say, because as angles in triangles sum to 180, don't forget your reasons. It's really important you write your reasons, because without reasons you don't get the marks. Even for the basic things, and obviously for the alternate segment theorem, you would have written, actually for the alternate segment theorem, you can just write alternate segment theorem, that's okay. So therefore, this little bit here is 47 degrees. And what are we trying to work out? ABD. Okay, so we've worked it out. So ABD is 47 degrees. Another way you could have done it is, you know that this is a chord as well. And all of this, so the angle between the tangent and the chord is equal to the angle in the alternate segment. So all of this must have equaled 72. So you know that this angle, 25 degrees, and this must sum to 72 degrees. So 72 take 25 is 47. That's another way you could have done it. There are loads of other ways that you could have done it, but essentially alternate segment theorem, cyclic quadrilateral is the key circle theorems that would have been used here, and hopefully they make sense. So here's another circle theorem. So ABCD are 4 points on the circle, BCE is a straight line, angle DAC is 25 degrees, and then we know that these two sides are the same as are these two. So I know that they're going to form isosceles triangles. Okay, so what can I do first? The ultimate aim is to work out what this angle here is. I can deal with that later. First, let's deal with what I know. So that's 25 degrees, which means that I can work out what these two angles here would be. So 180, take 25, is 155, divided by 2 is 77.5. And the reason I've done this is because AD equals AC, therefore triangle ADC is isosceles, and base angles of an isosceles triangle are equal. So it wants reasons, so that would be my reason. Next, I know that AB equals BC. AB equals BC, therefore triangle ABC is isosceles. So if I can work out any of the angles, then I know that I can do stuff with them. So let's try and think outside the box. So like I said, always have highlighters and highlight round just to see what shapes are present. You're always looking for either triangles, tangents, cyclic quadrilaterals, and in this case you have a nice cyclic quadrilateral here. Sometimes it's hard to spot, which is why I really push the highlighter technique. Just try and highlight as many different things as you can, otherwise you won't be able to do the question. So opposite angles, so we'll save this reason till later. So opposite angles in a cyclic quadrilateral sum to 180 degrees. Therefore, I can figure out what this angle here is. Therefore, angle ABC equals 180 take 77.5, which is 180 take away 77.5 equals 102.5 degrees. So this angle here is 102.5 degrees, and this is isosceles. Therefore, angle BAC equals angle BCA, as base angles are equal. And the working I do is 180 take away 102.5 divided by 2, because there's 2 of them. So 180 take away 102.5 leaves me with 155 over 2, which is 77.5. So 77.5 divided by 2 leaves me with 38.75. So these two angles are 38.75. Okay, so now I have essentially all the angles I need, because the last part is that this BCE equals straight line. So all angles sum to 180. Therefore, angle DCE must equal 180 take away 77.5 take away 38.75, which equals 180 take away answer take away 77.5 is 63.75. And those are all the reasons that you should give. So recognizing that it's an isosceles triangle, saying what that means, the cool thing about an isosceles triangle is it's got 2 equal sides and 2 equal base angles. Then spotting the cyclic quadrilateral, and then the last bit is just a straight line. So these are pretty simple steps. That the issue with circle theorems is spotting it. So highlight everything that you can to try and just pick out shapes and things, and always just start by working out the things that you know. And yep. Okay, so algebraic proof is really actually quite simple if you just know these few things. So in order to so imagine you have any number. And generally you call any number n. N could be 2, it could be 77, it could be 89, it could be anything. So n could be odd or even. I don't know whether it's even or odd because I don't know what it is, but I know that if I multiply anything by 2, it becomes even. Let's just try that. 2 times 2, that becomes 4. 77 times 2, that becomes 154. 89 times 2, that would become 178. All of these are even numbers. So in order to prove something is even, you just show that it's a multiple of 2, so you can times it by 2. So generally what we do is we say that any even number is represented by 2n. Okay, because if whether it's odd or whether it's even, if we times it by 2, it will still be even. So in order to represent an even number algebraically, we call it 2n. Therefore, in order to represent an odd number, if an even number is 2n, an odd number is always 1 more or 1 less than an even number. So 2n could be 2n, an odd number could be 2n plus 1, or you could represent it as 2n minus 1. And that's like the really basic key thing that you just need to know and understand. Then the other thing is knowing what consecutive means. So consecutive numbers are literally numbers that are after each other on the timeline. I mean number line. However, so a consecutive number, any number could be n. I haven't been told whether it's odd or even. I'm just stating any number. So any number could be n. Its next number, its consecutive number, would be n plus 1. The number after that would be n plus 2, and then n plus 3, and so forth. And that is how you do consecutive numbers if they are just any old bog standard number. Because if n was, let's say, 4, n plus 1 would be 4 plus 1, which is 5. N plus 2 would be 4 plus 2, which is 6. So that's how we get that. Now, the difficulty sometimes comes when it's saying consecutive odd numbers or consecutive even numbers. So if we look at our odd numbers, and let's say we started with 2n, because you're always going to, in order to prove something is odd or even, it needs to be 2n, because that's the only way you can prove that it's even, and subtracting from an even number is the only way you can prove that it's odd. So we're always going to be dealing with 2n. Or 2n plus 1 is our first thing. So the sum of the squares of 2 consecutive odd numbers. So I'm going to use 2n plus 1 as my first odd number. Now, the common mistake would be to say, oh, okay, well, the next one is going to be 2n plus 2. But no, because that would then be the next even number. Like imagine n is 7, okay? So if n is 7, 2n plus 1 is 14 plus 1, which is 15. But 14 plus 2 is 16. Okay, so that is why you always have to skip 1. So it would be 2n plus 3 would be the next consecutive number. If in doubt, literally just pick a number and substitute it in and see if that works for consecutive odd numbers. And then you'll be like, oh yeah. Okay, so this is where a little bit of difficulty arises in this question, but hopefully that made it a little bit clearer. So I need to prove algebraically that the sum, which means add, of the squares, so whatever it is, I'm going to square it, of the 2 consecutive odd numbers is always even. So my first odd number is 2n plus 1, and for it to be consecutive, it would need to be 2n plus 3. So what am I doing with these two expressions? That's my first odd number, that's my next odd number. I need to know that the sum of the squares of these, So I'm going to have to square these expressions and add them together. So let's have a go at doing that. That would be 2n plus 1, 2n plus 1, plus 2n plus 3, 2n plus 3. This is just an expanding brackets exercise, so I'm just going to do this quickly. So 4n squared, actually I'll just do the whole thing, plus 2n plus 2n plus 1, and then plus 4n squared plus 6n plus 6n plus 9. Some of you might have noticed that when you're expanding brackets like these, the middle two terms always combine, so you can just skip that step, but it's better be safe than sorry, to be fair. So I'm just simplifying this now. So 4n squared plus 12n plus 9. So these are the squares, okay, of two consecutive numbers. The sum of them I need to prove is always even, so let's simplify this expression. So that would be 8n squared, 4n plus 12n is 16n, and 1 plus 9 is 10. Now to prove that something is even, you just have to factorise it and show that it's a multiple of 2. So I'm just going to factorise that and take 2 out of it. So that would that could be expressed as 2 lots of 4n squared plus 8n plus 5. And then I just have to show, and I just have to like do a little sentence explaining what I mean. So anything, or let's go fancy. You could say 2n plus 1 squared plus 2n plus 3 squared can be written as 2 4n squared plus 8n plus 5, and anything that is multiplied by 2 is even. Therefore, I have proved it algebraically. Okay, so this is a little bit of a nasty, well, not nasty, just challenging question. Well, just not even it's just a long question that just requires you to go through the process. So the key thing that we need to remember is that in order to add or subtract fractions, they just need the same denominator. Okay, so that's the key thing that you just need for basic fractions, algebraic fractions, any kind of fractions. So what we want to do is probably just start with this bit and ignore the -3 till later. Just separate it and work on bit by bit and simplify it and then bring everything together. So in order to add these two together, I'm going to need to write them as fractions that have the same denominator. And in this case, because they're algebraic fractions, I'm just going to not worry about finding the lowest common multiple. I'm just going to write it as x minus 4, x plus 4. So what I do essentially is, let's say you had a over b plus c over d. The lowest, sorry, your common denominator would have to be bringing both these denominators together. So your common denominator would be bd. And then what have you multiplied this fraction by to get to bd? You've multiplied by d, so that would become ad plus cb, because what have you multiplied this by? You've multiplied it by b. So essentially we do exactly the same with algebra. So let's say it was a over x minus 4 plus b over x plus 4. What am I doing? My common denominator is going to have to be the two denominators multiplied together. And then you just think to yourself, what have I multiplied this by to get to this denominator? Well, I've multiplied by x plus 4, so I need to do the same to the numerator. And similarly here, what have I multiplied this denominator by? I've multiplied by this, so that would need to be like that. So hopefully that simplifies it a little bit, but that's why this becomes the denominator. So using that method, what have I multiplied this fraction by to get to this denominator? I've multiplied by x plus 4. So whenever you are changing a fraction, in order to keep it in the same proportion, you need to multiply whatever you've multiplied the denominator by, you need to multiply the top the numerator by the same thing, otherwise you change the value of the fraction. So that's why I'm doing this. So that would become x minus 3, x plus 4, plus, and then this fraction here I have multiplied by x minus 4, so that would be 2x plus 2, x minus 4. Now, let's just clear this up and make it a little bit neater. So, I write all of this under one fraction, x minus 4, x plus 4, and then this, x minus 3, x plus 4, plus 2x plus 2, x minus 4 is the next part of just like simplifying that. So generally with algebraic fractions, you're going to have to do some manipulation. You're generally going to have to expand the brackets, factorize them, just keep expanding and factorizing until something clicks. So over here, I know that my ultimate aim is to get the denominator in this form. And that's pretty simple because I can tell that this is going to be the difference of the two squares. So if I actually expanded that, x minus 4, x plus 4, x times x is x squared, 4 times x is 4x, minus 4x, and then minus 16. That cancels, so already I'm left with that. So you could start by just simplifying your denominator and show you're working like I have a small space to work in, but you have good working on your big page. So that's step 1 for the denominator. Working out 2, I'm going to expand this bracket. So x minus 3, x plus 4 is x squared, plus 4x minus 3x minus 12. So that would simplify to x squared plus x minus 12. And then I'm adding, this is where it's annoying running out of space. I'm adding, so that's my working for 1 and 2. Now let's do the working out for the third part. So this part here. So 2x plus 2, x minus 4, expand it, that would be 2x squared minus 8x plus 2x minus 8. Simplify, so minus 8 plus 2 is minus 6. So then you've got this, 2x squared minus 6x minus 8. Now, we can see if we can simplify it. So x squared plus 2x squared would give me 3x squared. X minus 6x is going to be minus 5x. And then minus 12 minus 8 is minus 20. So I'd be left with this, which I could factorize if I wanted to. There's a few, I mean, there are actually so many ways that you can do this. So the key is just expanding and factorizing and manipulating it until you can simplify it. But the point is that I have now simplified this to this. I could then factorize the numerator, but I'm not going to, not just yet. Because what I then need to do is subtract 3. So to turn any number into a fraction, you just write it as over 1. So that would become 3 over 1. But in order to add or subtract fractions, they need to have the same denominator. So because this is 1, and when I multiply anything by 1, it stays the same, this fraction is going to stay the same because all I need to do is multiply this fraction by x squared minus 16 so that they have the same denominator. So this would become 3 brackets x squared minus 16 over x squared minus 16. Now, what I can do is expand this. So that would become 3x squared minus 5x minus 20 minus, and then 3 times x squared is minus 3x squared, and then minus 3 times by minus 16 is going to be plus 48. Let's just double check because honestly, sometimes it's the simple things that lead to the whole question going wrong. So thankfully that's right. And that is all going to be over x squared minus 16. So let's clear this up and continue simplifying. So 3x squared minus 3x squared cancels. Then you're left with minus 5x, and then minus 20 plus 48. So 48 take 20 is 28. Have I missed something? Maybe not. No, I'm sure it's fine. So it's not always, sometimes people get really confused by this because they're like, it's not a positive. It doesn't matter. All it means is a and b are integers, which they are. So you could leave it as minus 5x plus 28 is over x squared minus 16. Or you could say 28 minus 5x over x squared minus 16, because it's just nicer not having a, what's it called, negative as the beginning. And you need to find the value of a and the value of b. So the value of a is minus 5 and the value of b is 28. There is a possibility I may have slipped up somewhere, but I'm trying to get this done so it can be released in time. So if I have, call me out on it and I'll correct it in the comment. Okay, so the next up is another slightly tricky algebraic fraction one. This time it's division. So with adding and subtracting, you need the same denominator. With division and multiplying, you don't need to bother. You don't need to worry about denominators, okay? All you need to know is for multiplication, you just multiply the numerators together and you multiply the denominators together. And then for division, you remember keep, change, flip, and that's it. So show that this can be written in that form. So all we're going to do is keep the first fraction as it is, change the second fraction. So 8x cubed, or this should be pink because it's a pink thing. So 8x cubed divided by 4x squared minus 36 times by 2x minus 3 over 4x to the power of 4. Now, you might not, but hopefully you're getting good at spotting the difference of two squares. So the difference of two squares is literally where you have a square number, x squared, minus another square number. And the way the difference of two squares factorizes, it's always going to be x plus the square root of 16, x minus the square root of 16. So essentially x plus 4, x minus 4, like the square root of whatever your number is. So in this case, I know that this is going to factorize to 2x plus 6 and 2x minus 6, because 4 is a square number, so the square root of 4 is 2, and 6 is a square number, and the square root of 6 is 36 is 6. And the reason this always works is because when you expand it, because you've got one positive and one negative term, the middle two terms, they always cancel out. So let me just show you, if you don't believe me, that would become 4x squared minus 12x plus 12x minus 36. So this and this cancels out, and that is why you're left with 4x squared minus 36. So it's really important that you always look out for things like that, because in this case, I'm pretty sure it's going to matter. So I'm just going to rewrite that to make my life easier. So 2x plus 6 and then 2x minus 6 times by, and already I can see that that's making a difference. So if I expand this, that would be 2x minus 6 over 4x to the power 4. Now remember, when you're multiplying, you just multiply the numerators together and the denominators together. So that would be 8x cubed times by 2x minus 6 over 2x plus 6, 2x minus 6. You could write it like that if you wanted to. I'm just writing it like this just to show you, so that it might make it a little bit easier. So then remember, with a fraction, if you had, like, let's say 5 times 4 divided by 5, well, 5 divided by 5 is 1. So anything, so that would just end up being 4 over 1. So whenever you have anything on the top of the fraction that is the same as the bottom of the fraction, oops, was that minus? Yeah. They cancel out so long as the numerator and the denominator are products, which means every term is being multiplied. And it can be like things inside a bracket count as one can count as one term, sort of. So I've then simplified this, and let's rewrite it over here. So once I've cancelled that out, I end up with 8x cubed as my numerator, and then 4x to the power 4 times by 2x plus 6. Now, there is a little bit of a hint over here. I know that I'm going to eventually divide, I want my numerator to be essentially divided by 8x cubed. So what that means, because I want it to be 1, the only way to get 1 is to divide 8x cubed by 8x cubed. So what that means is that I could take out a multiple of 2 from the bracket. So that could become 8x cubed divided by 4x to the power 4 times by, if I take out 2 out of the bracket, I'd be left with x plus 3. And 4x to the power 4 times by 2 is conveniently 8x to the power of 4. So I'd be left with 8x to the power 4 times by x plus 3. Now, if you're not confident with indices and you look at that and you're like, oh, I'm just brain fried, literally just take it back to its basics. So what does 8x cubed mean? It means 8 times x times x times x, and then 8 times x times x times x times x times by x plus 3. That's in a bracket. So what can cancel out? Well, 8 divided by 8 is 1, x divided by x, x divided by x, x divided by x. So the whole of the top cancels out to just 1. And on the denominator, you are left with x plus 3 and 1x on the outside. And there we have it. They haven't asked you what a is, but if they did, you would say that a is 3. So hopefully that helped a little bit. And the key is just keep going with the question and see where it takes you. Okay, so here you have been given a question that requires you to use the area of a triangle. Now, the area of a triangle is half AB sine C. It is given to you on the formula sheet, but you need to know how to use it. So I'm told that the area of triangle ABC is 4 root 3 meters squared, and I need to find the value of x, which is located here. So let's think about what I can do. First things first, with advanced trigonometry, you want to label your triangle, and remember, you can ignore the labels they have given you. So remember, the big letter relates to an angle, and the little letters, so A and B, relate to sides. So I want C to be over here. That means this is going to be little c. It then doesn't matter which is A and B, so I'll just call this one A. So it's going to be big A, and this is B, and this will be little b. So now I've labelled it, I can substitute into my formula. I know that the area is 4 root 3, so I'm going to say 4 root 3 must equal a half times by A, which is this, x plus 2, times by B, which is this, 2x minus 3, times by sine C. And sine C, well, C, angle C, is 60 degrees. So what can I do? Well, I can simplify first. So I know that, let's rearrange it so it's all of the things that I can divide by. X plus 2 brackets 2x minus 3. So this is the algebra over here, and this is the numbers. So what I can do is just divide both sides by a half times by sine 60. You can do it, but step by step. So I could have done 4 root 3 divided by half and then divided by sine 60, or you could do it actually fine. Let's do it in step by step, just so that I don't confuse anyone. So I'm timesing by a half. So step 1, I want to divide both sides by a half. So dividing by a half is the same as timesing by 2, but if you're not sure, still just enter it into your calculator. and you'd see that that becomes 8 root 3. So 8 root 3 equals sine 60 times by this. And then I'm just going to have to divide 8 root 3 by sine 60, which is 16. So essentially what you've done is, first of all, you have just substituted into the formula, and then what you're doing is you're trying to look for all of the values that are numerical and just move them to the other side of the equation. So you're just left with the algebra on one side and numbers on the other. So let's expand the brackets. So x times 2x would be 2x squared. X times minus 3 is minus 3x. 2 times 2x is 4x. And 2 times minus 3 is minus 6. So I know that 16 is 2x squared. Minus 3 plus 4 is 1 minus 6. Okay, so now I have a quadratic. And what do you do in order to solve a quadratic? In order to solve a quadratic, you need to get it, rearrange it so it's equal to 0. So we're going to subtract 16 from both sides. So I'd be left with 2x squared plus x, and then minus 6 minus 16 leaves me with minus 22 equals 0. And you could use the quadratic formula. So I'm just going to go ahead and use the quadratic formula. So with every quadratic, you know that it can be expressed in the form ax squared plus bx plus c. So therefore, with this equation, I know the value of a is 2, the value of b is 1, and the value of c is minus 22. So I'm just going to substitute that into the quadratic formula. So x is going to be minus 1 plus or minus the square root of 1 squared minus 4 times 2 times minus 22 over, and then 2 times a is 4. So I can simplify that. It would be 1 take away, and then 4 times 2 times negative 22 is 176. So that would be the next step. And then the final step is minus 1 plus or minus the square root of 177 over 4. So therefore my final answers are going to be x is minus 1 plus root 177 over 4. Or x is minus 1 minus 177 over 4. So these would be my two solutions, and let's see what they bring. So minus 1 plus 177 over 4 gives me 3.076033. And then if I just use the little arrows, oh, I deleted it, but you can just use the little arrows to change it, so you don't have to type the whole thing out again. But obviously don't worry if you do, because I just had to, because it deleted itself. So, or x is minus 3.57603. Now, because I'm dealing with a length, I know that it can't be negative, because you can't have a negative length. A length is like a thing that exists in the 3D world. It can't be negative. Like, you can go underwater with a length, but the length is still positive. So whenever you have any kind of length, this cannot be a possible solution. This is your only solution. And it says give your answer correct to 3 significant figures. So x is 3.08. And that's that question. Okay, so here I've got two triangles, non-right angled triangles. So even if the little helpful thing at the top in the right hand corner didn't tell me what I was going to be doing, you should think to yourself in an exam, two triangles, none of them are right angled, so I'm going to be using sine and cosine, or area of a triangle. So let's have a look. I have triangle ABD and DBC, and I need to work out the length of AD. And then I need to give my answer to 3 significant figures. Okay, so the triangle that I have the most information for is this one here, and that makes sense because in the exam they're not going to just give you everything and give you a useless triangle. So let's start with this one here. So I've got 105 degrees, I've got an angle, another angle, a side, And what would be useful for me, considering I'm going to be working on this triangle, is to figure out what this side here is. So I've got a side and its corresponding angle, and an angle and its corresponding side. So a good thing to use here would be the sine rule. So I'm trying to work out a side, and remember, whatever you're trying to work out, you want to be the numerator. So I'm going to say A over sine A equals B over sine B, and just substitute those values in. So this could be A, and this would be big A, this would be little b, sorry, big B, this would be little b. Remember, the side, the angle is the big letter, the little letter is the side, and they're always opposite each other. They're corresponding to each other. So A over sine 28 must equal B, 13.2 over sine 105. Therefore, A must equal 13.2 over sine 105 times by sine 28. So a nice and easy one, really, to begin with. So I'm just rearranging it to make A the subject. This is why rearranging formula is so important. So 13.2 over sine 105 times by sine 28. Didn't close the bracket. Let's just check. Yeah. So A is 6.415631. So this length here is 6.41. I'm just going to write it out here on the top just to save for later in case I need it. That's just what I always do, because it's an exam. I want to be careful. So 6.415631,988. Okay, now I have a side. I have a side here. Can I work out anything else? No. And yeah, okay, so this is one angle. I only have one angle. Generally, if you only have one angle and you have two sides and you're trying to work out a third side, you're going to be using the cosine rule. So the cosine rule is a squared equals b squared plus c squared, take away 2bc cos a. So once again, you label your triangle according to what you want. So the only angle you've been given is this one, so I'm going to label that A. And the side I'm trying to find is the little a. That's the cool thing about the cosine rule. If you have the angle opposite to the side that you're trying to find, and you have the lengths of two other sides, then the cosine rule is a dream. So a squared is going to, and this, it doesn't matter which one's B, which one's C. So a squared equals, is it still memorized? Yep. 6.41 squared plus 8.9 squared. Oh, I put them the wrong way around, but it doesn't matter. Times by 2 times 6.4 times 8.9 times by cos 83. So a squared is equal to, so I've got my answer, squared plus 8.9 squared equals 120.3703338. I always tend to just do it in two parts just because it minimizes the risk of a miscalculation, a typing error, exam madness. It just happens. So 2 times by 6.415631988 times by 8.9 times by cos 83 is 13.91726567. A squared is therefore going to be 120.37. Take 13.917, and that gives me 106.4530681. To work out A, I'm going to do the square root of this. So A is the square root of answer, which is 10.317. And that is what I'm trying to find out. I'm trying to find out the length of DA, and that is A. So A equals 10.3 to 3 significant figures. Okay, so 3D trigonometry is just about trying to visualize triangles everywhere, essentially. So ABCDEFGH is a cuboid, and FE has a length of 8 centimeters, and it's a cuboid. That means that this length here is going to be 8, this length here is going to be 8, as is this length here, so that's pretty cool. AE, so this diagonal here has a length of 12 centimeters. So already we should be able to see that there's a triangle that's formed there. That would be 12 centimeters, that's 8 centimeters. And I could use Pythagoras to work out what this length here is, if I should need to. I'm guessing I most likely will. So I'm just going to work it out. So 12 squared, take 8 squared equals, and then the square root of 80 is 8.9. So AF and any of these vertical heights is going to be 8.94427,191. So I know that. What else do I know? I know that angle GFE, so GFE is going to be here. So GFE is this angle here. Okay, and I need to find the size of angle EDG. So EDG, okay, right. So I wrote the wrong angle. It's angle FEG, because that wouldn't make sense, because this would be a right angle. So if I just drew this as a plan, this is what it would look like. Basically the intersections of two, with these it's like sometimes really difficult to visualize, but imagine a literal box, like I don't know why I have a breadstick box here, but imagine anything that you've had in a cardboard box, and imagine laying it flat, and you can see that there'd be right angles at every corner. So that's how we know that we use trigonometry. So this would be a right angle, and this angle here is 39 degrees. And then we know that this length here is 8. We haven't been told this length here, but this length here is going to be useful because I need to find the size of angle EDG, which is going to be this angle here. So it's going to be a right angled triangle that is formed using the hypotenuse of this triangle here. So it's about kind of seeing where they all interlink, but it is hard. It's especially if you're not a visual person. I get that it is tricky to try and visualize it. So hopefully you can see that if you laid it flat, it would be a right angle triangle. Okay, so what have we got? We've got our basic trigonometry. So I used Pythagoras. I am rushing a little bit because I created a mammoth of a thing. I don't know why I did that, and time is ticking. So what are we doing? We're doing SOHCAHTOA. So what am I trying to find? The hypotenuse. That's the hypotenuse. I've been given the adjacent. Which one uses A and H? That's K. So I know that cos 39 equals adjacent 8 over hypotenuse. So therefore the hypotenuse is going to be 8 over cos 39. So 8 divided by cos 39 equals 10.294. So I know that, what was that letter here? GE. Okay, so I know that GE is 10.29407,653. And the next part is using this triangle here to work out this angle here. So if that's D, that's E, and that's G. DE, I've already worked out that length is 8.9. And the hypotenuse, I've just worked out that that length is 10.29. So therefore I can once again use Pythagoras. So I've got SOHCAHTOA. What have I been given? So this is my given angle. This is the hypotenuse. This is the adjacent, and this is the opposite. So therefore I'm using O and A. So tan theta is opposite over adjacent. So tan theta, and theta just represents the angle. Opposite is 10.29 over 8.94. So answer divided by 8.94 to 7191 equals, so tan theta is 1.1509. So therefore theta is going to be shift tan answer, which is 49.013402. So just give your answer to the nearest degree. So EDG, angle EDG equals 49 degrees. And that's how we do 3D trigonometry. Even if you just manage to do the first bit of the Pythagoras, of the finding the sides, of doing a little bit, every tiny little bit counts. It doesn't matter. Honestly, just picking up marks wherever you can, like a little vacuum, just scooping up everything is the best way to get the best grade. Like, you can get a grade 9 by making the silliest mistakes and not even doing the last two, like, you know, just marks are great. So just never give up on a question and always try and just scoop up something. Okay, so sometimes iteration shows up like this, where you're being asked to show that and use the formula to find an estimate for the solution. So I just thought I'd go through this type of question as well. So here you're being told to show that the equation x cubed plus x equals 6 has a solution between x equals 1 and x equals 2. So the first thing you want to do when you've got a question like this is to rearrange it to make it equal to 0. So x cubed plus x minus 6 equals 0. And then what we want to do is substitute the values that they've given us. So, I mean, most of the time it's already going to be equal to 0, but just in case it isn't, I put one like this. So first of all, we substitute the values. So we'd say 1 cubed plus 1 minus 6 equals, so 1 cubed, 1 plus 1 is 2, 2 minus 6 is minus 4. So when I substitute 1, I end up with minus 4. Then I try and do the same with x is 2. So 2 cubed plus 2 minus 6 equals 8 plus 2, which is 10, minus 6, which is 10 minus 6 is positive 4. So when I substitute 2 in, I end up with 4. And what that essentially means is wherever your cube graph is, the solution is going to be between -4 and 4. So when x, sorry, I'm very tired. Essentially, you are saying that if there's a change in sign, so if it goes from a negative to a positive, it means that it must have crossed the x-axis. So that is all you are saying. So when you are trying to show that an equation has a solution between two values, you substitute those two values into the equation, and one of them is going to be a negative, one of them is going to be a positive, and you say there is a change in sign, therefore the solution lies between 1 and 2. So because there's a change in sign, that means that the graph must cross in between those values. Sorry, I really need a coffee or something. Okay, right. For the next question, show that the equation can be rearranged to give this. All you're doing is you're trying to rearrange this equation in the form that they want. So x cubed, you can see that you have 6 here and that you're subtracting x. So the first thing you want to do is just take x from both sides. So x cubed is going to be equal to 6 minus x. And then the next step is you cube root both sides. So x equals the cubed root of 6 minus x. Very simple generally, but it's just not always, so it's not generally going to be the instinctive way you're going to want to rearrange. It's rearranging in a way that they have instructed you to. So just be mindful of that. Look at what they want you to rearrange and then use that to give you clues. And then starting with x equals 2, use the iteration formula. So remember, with iteration, all this means, don't be afraid of the fact that it's got like so it's like a bottom indice or whatever. All it means, oh, and that should say xn over there. So all it means is, imagine that just means the next term, and that is the original term. So xn is the original term, xn plus 1 is literally the term after that. So if x0 equals 2, well, x0 is the original term. So to work out x1, I'm going to need to do the cubed root of 6 minus, like if I'm using the formula, xn. But in this case, it's going to be 2 because I used the previous term. So like to work out the next term, which is x1, n plus 1, I've used this. Then to work out x2, I'm going to do the same, except whatever this answer is, which I need to type into a calculator, that's going to be my answer there. Now, really quickly, I have gone through this before, but just in case, whenever you're using iteration, and I'm explaining this very poorly, but I'm really not feeling well, so I'm trying to power on through. Okay, step 1 is, you know that the first term is 2. So you press 2 equals, okay, into a calculator. You press 2 equals. If it said x0 is 17, you press 17 equals. Then what you do is you type in the formula. So in this case, you're going to type in the cubed root of 6 minus 2, okay, like that. And then you're going to press equals again. And that's going to tell you the first term. So that is 1.587401052. And now what you do is you use the little arrows and you go and you press delete where the 2 is, and instead you press answer. And then it automatically calculates it for you. So 1.640205079, and then x3 is going to be the same. Take away answer. So technically this is that, and this answer is that. The calculator has stored that for you. You just press, and it gives you 1.633636622. You keep on pressing equals, and it gives you the next one. So x4 would be 1.6344. x5 would be 1.63435. Now, it says to find an estimate for the solution. Sometimes it's going to tell you try this iteration 3 times or 4 times. If it doesn't, then what you're looking for is the place where they all round to. So with the 4th and the 5th term, actually even this would round to 1.634. So 1.634, that would round to 1.634. So essentially, when you've got 2 or 3 terms that round to the same thing, you know you've done. But if you kept on pressing equals, you see, like, literally you get closer and closer and closer and closer to the value. So that is what we do if they haven't told us how many times to use the iteration formula. We'll just keep on doing it until we see a similar, like at least 2 of the decimal points would round to the same point. So really, actually very poorly explained iteration. I've done lots of videos, go through the past papers on iteration, even just go on paper 2. I'm just really flagging right now, but got another 12 questions to go, so woohoo. Okay, so the number of cows on a farm at the end of the month, N, is CN. So once again, it's iteration. It's just this time it's in context. The number of cows at the end of the next month is given by this. Once again, don't be afraid of this. This just means the original term, and N plus 1 just means the next term. So at the end of September, there are 1,500 cows on the farm. So we can say that our original term is 1,500, and that's the end of September. Work out how many cows there will be on the farm at the end of January. So, okay, the end of September is our original month. Then you've got October, November, December, and January. So C1, or like we could call that C0, September, the end of September is the original value, is 1,500. At the 1 month after that, at the end of October, that's going to be C1. This would be C2, this would be C3, this would be C4. It essentially means like the first term, second term, third term. So C1 would be calculated by doing 1.3 times by like the previous original value, so 1,500, take 200. So let's actually get rid of this. So essentially you're trying to work out C4 because that would take you to the end of January. So what is this? Once again, you can do the little trick I told you. So 1,500 is your original term. You press equals and then you type in, and you're going to put it in brackets because that's being multiplied first. So 1.3 times by 1,500, close the brackets, take 200 equals 1,750. So C2 is going to be, I'll just write it out both ways actually because I explained the last one so poorly. So that would be 1.3 times by 1,750, take 200, or you just type it into a calculator and you, wherever you see 1,500, you press answer and then it works it out for you. So that'd be 2,075. C3, you do 1.3 times 2,075 because each time you're literally just substituting the previous term in. So that's your previous term. Here, that's your previous term. But anyway, I'll write it out just so that it makes sense if you haven't done this before. And that's 2497.5, and then C4 is going to be 1.3 times 2497.5, take 200 equals 3,046.75. So I did that all on the calculator. I just wrote it out so that you can see how you could do it if you're a bit confused as to how to do it on the calculator. You're substituting the previous term, the previous answer to get the next one. So either think about it as the original and then this is the next term, or think about it as to work out this term, I need to substitute the previous answer in. And that's literally what you do in order to do iteration. And I'm just gonna double check because I was using the calculator. 1.3 times 2497.5, take 200 equals that. Okay, yeah, okay. So hopefully that's all right. Hopefully that makes sense. Okay, so here we've got an upper and lower bounds question, and if this is the kind of thing that you hate and you get confused by, I'm just going to show you what you can do if you're like, I'm going to leave this question. So I'm going to show you what not to do and just literally how to get some marks, even if you hate these kinds of questions. So the first thing is you want to actually just consider the bounds. And I know that everyone can do that because it's just thinking about rounding. So a dog race is measured to have a distance of 2.8 kilometers, correct to the nearest 0.1 kilometers. Okay, so it's 2.8 kilometers, correct to the nearest 0.1 kilometers. So all we do is we say, okay, what is the 0.1 kilometers surrounding 2.8, i.e. to 0.1 kilometers, in this case, it's one decimal place. So it's literally, what are the decimal places surrounding 2.8? That would be 2.9 and 2.7. Now the bounds, that would be the midpoint, okay? So the minimum value, it could be, the lower bound would be 2.75 and the upper bound would be 2.85. Now there's a lot of debate and personally I think it should be 2.849 recurring, but just for simplicity we acknowledge that if it was an error interval, it would be 2.75 is less than or equal to x, which is less than 2.85. But just so that, for whatever reason, we just say with bounds, essentially it's the midpoint. So that's the upper bound for the distance. Okay, so everyone can work out the upper bound and the lower bound. All you do is you write the thing, and then whatever it's saying, so it's saying to the nearest 0.1, literally write one decimal place on the right, one on the left, and then you just find the midpoint. Then let's do the same for the speed. Now, okay, it is a little bit tricky because it's got like seconds and all of that, but 5 minutes, 45 seconds, correct to the nearest second. All we need to do is consider the seconds. So 45 seconds to the nearest second. What are the seconds surrounding 45 seconds? That would be 46 and 44. So halfway is the upper and the lower bound. So that would be 44.5 seconds and 45.5 seconds. So the lower bound for time would be 5 mins and 44.5 seconds. And the upper bound would be 5 minutes and 45.5 seconds. So that is for time. Now, this is a tricky question because it's just involving a lot of calculations, but hopefully the minimum that we can get is the upper and the lower bounds. And that's marks. You're just sweeping them up, okay? So I'm told that shadows, okay, so basically I haven't even read out the question. Essentially, a dog race is measured to have a distance of 2.8 kilometers, correct to the nearest 0.1 kilometers. So the distance is roughly 2.8 kilometers. The time is 5 minutes, 45 seconds, correct to the nearest second. I've established my upper and my lower bounds. And now I need to work out the speed to a suitable degree of accuracy by considering bounds. Now, whenever you see this question, and if you, obviously this is quite last minute, so what I'm going to tell you to do, if you have the time, just work out each possibility. So for instance, in this case, how do you work out speed? Speed is distance over time. So you're going to have 4 answers. So you're going to have lower bound of distance divided by lower bound of time. You're going to have lower bound of distance divided by upper bound of time. Then you're going to have upper bound of distance divided by lower bound of time, and upper bound of distance divided by upper bound of time. So essentially you're matching each bound to each other. So there's a combination that includes all of them, and that will mean there's 4 combinations. So that is the worst case scenario, because all you're doing then is just substituting values in, and then you're going to get some answers, and then you're going to figure them out. But that is the worst case scenario, and let's actually read the question because I think it actually wants more from us. So the key thing here is that it said speed in this race is something kilometers per hour. Now, his time is in seconds, so it's already kilometers, but it's kilometers per hour that is needed. So I know that 5 minutes is 5 times 60 seconds, because there are 60 seconds in a minute. So 5 times 60 is 300. Okay, so first thing I'm going to do is turn my time into purely seconds. So the lower bound of time is going to be 344.5 seconds. And the upper bound of time is therefore going to be 345.5 seconds. Now, what I'm going to do, because I need to convert this into hours, 1 hour is 3,600 seconds. So therefore, to get from seconds to hours, you divide by 3,600. So 344.5 divided by 3,600 equals, the this is nasty, but it's a calculator paper, so that's fine. So the lower bound of time is 0. Actually, I'm just going to write it up here because it's long. So the lower bound of time is 0.095694 recurring. The upper bound of time is going to be 345.5 divided by 3,600, which is 0.095972 recurring. Okay, so that is my time in hours. Whenever I'm dealing with speed, generally you're going to have to deal with your time as a unit of an hour. Normally it's minutes to hours, but now it's minutes and seconds to hours, but that's still fine. So what to do next? Right, so I know that that is the time, I know the distance, so let's go back, and I know that speed equals distance divided by time. Now, either you do what I tell you to, which is you put all 4 options together, because then you can see, you just have all 4 options and you don't have to do anything confusing, or you think about how could you get the biggest variation. So you essentially want the max speed and the minimum speed in order to figure out what you could round it to. So to work out the maximum speed, and this is where it's sometimes helpful to just pick 2 numbers. So if I literally picked 10 and 2. So 10 is my upper bound, 2 is my lower bound. What gives me the biggest output, biggest value? So 10 divided by 2 is 5, and 2 divided by 10 is 0.2. So when I do upper bound over lower bound, that gives me a max value. And when I do lower bound over upper bound, that gives me the minimum value. So you can use that shortcut if you already know that you just do these 2. If not, then just do all 4 options and you'll get something. So let's do that. So to work out the max speed, I'm going to do upper bound divided by lower bound. So upper bound of distance is 2.85 divided by lower bound of time is 0.095694, which is 2.85 divided by 0.095694 is 29.78229318 kilometers per hour, which is pretty fast. Cocker Spaniels are very fast and amazing creatures. So the min speed is, I'd need the lower bound of distance, so that would be 2.75 divided by the upper bound of time, which is 0.095972 recurring. So let's just type that into the calculator. 2.75 divided by 0.095972 recurring, and that is 28.65412,446. So this is like the fastest way to do it, using those 2. But like I said, if bounds is something that you struggle with, just do all 4 options. Like just mix them together and then you'll get 4 answers, and then you'll be like, oh, well, to 1 decimal place, they all round to this. So it says by considering bounds, calculate the value of S. So this is the maximum speed. This is the minimum speed. Well, let's see. What do they round nicely to? That's a bit annoying. So it would be very nice if they rounded to 1 decimal place. So if I rounded it to 1 decimal place, that would be 28.654 7, and this would be 29.8. So I'd have to round it. If I rounded it to the nearest whole number, that would be 29, and that would be 30. So I'd have to actually round it to one significant figure. So I'd say 30 kilometers per hour to one significant figure. And if you had the other two values, you would have just got two values that are in between, and you would have come to a similar conclusion. But that is how we do bounds. Okay, so here I've got a quadratic sequence, and I am told to find an expression in terms of n for the sequence. So the first thing I do, just like I would with a linear sequence, is just figure out what the term-to-term difference is. So from 7 to 13, what do? I add 6. From 13 to 27, what do? I add 14. From 27 to 49, I'm going to use a calculator because the brain is really flagging right now. 49 take 27, I add 22, and 79 take 49 is 30. So that is the first difference. Now, with a quadratic, the first difference isn't going to be the same. So what we do is we then find the second difference. So 14 take 6 is 8. 22 take 14 is also 8, and 30 take 22 is also 8. So my second difference is 8. Now, whatever the second difference is, halve it. And then that tells you what n squared the sequence is going up in. So it might be useful to just remind yourself of what the square numbers are. So it's 1, 4, 9, 16, 25. So this sequence is going up in the 4n squared times tables. So it's just helpful to just write it out. So if n squared is 1, 4n squared would be 4. 4 times 4 is 16. 9 times 4, it's really flagging. 9 times 4 is 36. 16 times 4 is 64. So this is the quadratic sequence it's going up in. So what I can do then, once I found my second difference and I halved it, that tells me what n squared is going up in. So I know it's going up in the 4n squared times table, so that will be the first part of my sequence. I then write out this second sequence above my original sequence. So that would be 4, 16, 36, 64. And what I want to do is find out, so I could do it in a table as well. So 4n squared and then original sequence. So 4n squared is 4, 16, 36, 64. The original sequence is 7, 13, 27, 49. And what I want to do is figure out what the difference is between the 4n squared times table and my sequence. So how do I get from 4 to 7? I add 3. How do I get from 16 to 13? I take 3. From 36 to 27, I take 9. And from 64 to 49, I take away 15. Okay, so then I have this new sequence that's going to tell me the next part. So I know the first part of my sequence is 4n squared, and the next part is just work out the nth term of this sequence. Okay, so the sequence is 3 minus 9 minus 15. What's the difference? Well, it's going down by 6 each time. So the nth term of this sequence, if it was the minus 6 times tables, is minus 6n. And then how do I get from minus 6 to 3? I add 9. From minus 12 to 3, from minus 12 to minus 3, I add 9 as well. From minus 18 to minus 9, I add 9 as well. So the nth term of this sequence is minus 6n plus 9. So once you've got that, you just lumber it on to this. So my full sequence would be 4n squared minus 6n plus 9. So step 1, find the second difference, halve it, and that tells you what n squared times table it's going up in. Then work out the difference between the n squared and your original sequence. You could have done it like this if you preferred, whatever you prefer. And then you just work out the nth term of this sequence, and that tells you the whole thing. So the nth term of this sequence is 4n squared take 6n plus 9. Now I'm next being asked to find the 20th term of the sequence, so all I do is I substitute n equals 20. If I was asked to find the 40th term, I'd substitute n equals 40. So that would be 4 times by 20 squared, take away 6 times 20 plus 9. So 4 times 20 squared is 1,600, take away 120 plus 9. So 1,600 take 120 plus 9 equals 1,489. And that's how I'd do that. I know there are other ways, I don't like them, but if you know the other way and you get the same answer, absolutely fine. Okay, so in this question, Shadow, my dog, he had buried some of his favourite sticks and toys in the garden in the ratio 7:5. Miss Costa, he goes out to find some of his sticks and toys so they can be washed because they get very dirty when they've been buried in soil. And the ratio of sticks and toys left buried in the garden is now 10:4. I managed to find 4 sticks and 6 toys. How many sticks and toys had Shadow originally buried? So the original ratio is 7:5. And what has happened now? The ratio is now 10:4. So what I can do is, I know that, I don't know exactly how many there were, but I know that it was in the ratio 7:5. So however many sticks there were, 7x to 5x, I can write that as an expression. And the reason I do that is because there aren't 7 toys as 6 and 5 toys. I just know that it's in the ratio, so it could have been 14 to 10, it could have been 21 to 15. So whatever x is, it's a multiple of however many sticks and toys there were. So I could say that the original amount would have been 7x to 5x. And now what has happened is I have managed to find 4 sticks. So however many sticks there originally were, there's now 4 less. And however many toys there originally were, there is now 6 less. And that makes the ratio, 10:4. Now, when you've got 2 ratios that are equivalent, you can form equations. So just like, I don't know, if I said the ratio of 2 to 3 equals the ratio 4 to 6, I could write that as 2/3 equals 4/6. Okay, so when you've got equations and equivalent ratios, you can write it like that. So I can write this equation as 7x minus 4 over 5x minus 6 must be equal to 10/4. I've then got a nice little equation that I can solve. So 7x minus 4 over 5x minus 6 equals 10/4. What can I do? Well, if you know the trick, you can just cross multiply, but let's do it step by step. So if I times both sides by 4, I'd be left with 4 lots of 7x minus 4 over 5x minus 6 equals 10. And then I can multiply both sides by 5x, take 6. I'm just multiplying both sides by the denominator. So I'm left with 4 brackets 7x minus 4 equals 10 brackets 5x minus 6. And now I just have a double-sided equation that I can solve. So let's expand it. That would be 28x minus 16 equals 50x minus 60. And you never want to have a negative x, so we're going to take 28x from both sides, and that would give me, I'm just going to double check because like I said, brain is fried. 50 take away 28 is 22. So minus 16 equals 22x minus 60, and then minus 16 plus 60 is 44. So therefore 22x equals 44. So divide both sides by 22. I know that x equals 2. So if x is 2 and originally there was, the original ratio was 7x to 5x, then 7 times 2 is 14 and 5 times 2 is 10. So originally, sneaky thing, he had buried 14 sticks and 10 toys. And in fact, even though I cleared out the whole house, I'm sure there's still something buried there that I will come across in the future. Okay, so now a functions question. So remember so basic functions, all you do, so let's say you needed to find f of 5. All that means is literally wherever you see an x, substitute 5 into it. So in this case, you just find the cubed root of 5. Okay, so that's the basic functions, and if they appear, you should be like, woohoo, lucky day. All I do is substitute the thing in the brackets and replace it for x. But we've got a slightly trickier question here. So we've got composite functions, which means like you put a function inside another function. So we always start from the inside out. So wherever like the thing in the brackets is, you work out the letter next to it first. So first we're going to work out what g of 5 is. So g of 5 would be 3 times 5, which is 15, plus 4. So I know that g of 5 is 19. All you do, literally just substitute. And then you want to find f of g of 5. So once you know that g of 5 is 19, you're essentially working out what f of 19 is. You find this, work out what its value is, and then you substitute it into the other thing. So f of 19 is the cubed root of 19. And this is a calculator paper, so maybe leave it as a cubed root of 19 because it's more specifying. But if not, then you type in cubed root 19, which is 2.66840169. That is all. Okay, so for a composite function, that is all we're doing. Now, next question is find the inverse of h. So this is a little bit of a tricky one. It's saying that h of x is f g of x. Okay, so g of x is 3x plus 4. So what we're doing, because this is now algebraically, we don't have anything to substitute into it, so we substitute the whole thing. So g of x is this whole thing, and what we do is wherever we see an x, we substitute that in. So fg of x is going to be the cubed root of 3x plus 4. And I know that h of x equals this. So h of x is the cubed root of 3x plus 4. And I need to work out the inverse. So what I do, I don't have time to go into it in detail, but essentially we just write it as y equals the cubed root of 3x plus 4. So instead of this, we just write y equals. Then we switch the variables around. So switch the y and the x around. So that would be x equals the cubed root of 3y plus 4. And now all we're doing is we're solving it, rearranging it to make y the subject. So first thing you would do is cube it. So x cubed equals 3y plus 4. Then we would take 4 from both sides. So x cubed take 4 equals 3y. And the last part would just be to divide by 3. And once we've got to that part, we switch the y, we replace it with h minus 1 of x equals x cubed minus 4 over 3. And that's how we do an inverse function. So the key step is write it out as y equals, switch the variables, and then solve to make x the subject, and then, y the subject. What am I talking about? Yeah, that is what you do. Right, okay, so g of f of x solve. Okay, so this kind of question, first of all, we need to figure out what g of f of x is. So f of x is this. Okay, so we're putting that into g. So wherever we see an x, we're putting this. So g of f of x equals 3 lots of the cubed root of x plus 4. And I know that this equals 20. So I'm just going to say 20 equals 3 lots of the cubed root of x plus 4. So once again, it's just rearranging to solve. So take 4 from both sides. So that would be 16 equals 3 lots of the cubed root of x. Then we can divide both sides by 3. 16 over 3 equals the cubed root of x. And what's the final step? Well, x is being cube rooted, so we're going to have to cube both sides. So 16 over 3 cubed equals x. And I can just type that into my calculator. So 16, oh, so where is the cube? I hate this new calculator. What am I doing? I'm trying to write a fraction, put it in brackets, okay? 16 over 3 cubed. Ugh. Okay, so that equals 4096 over 27, which if I turn it into a decimal is 151.7037. Hasn't asked me what to round to, so I don't need to worry about that. I could even leave it as a fraction. Okay, so here we have a slightly tricky functions question, but it's not that tricky if we just go through the motions. So I think a lot of the time people just think it's a really hard question because they haven't actually tried it. They just look at it and they're like, ooh. So just always try a question. So I'm told that the functions f and g are such that f of x is 3x plus 2 and g of x is ax plus b. I'm told that g of 5 is 28. Okay, so that's great. So I can use that to my advantage. So g of 5 is when I've substituted the value of 5 for x. So that would be 5a plus b. So I know that 5a plus b must equal 28. Okay. Don't know what I'm going to do with that yet, but I know that that is the case. Then I'm told that f of minus 1 of x, that should say, is 32. No, this shouldn't say. Oh, I'm so tired. Right, so first of all, I know that f of x equals 3x plus 2. So I have to do the inverse again. So what do? I make it equal y equals 3x plus 2. I switched the variables, so x equals 3y plus 2. I rearranged it to make y the subject. So I take 2, so x take 2 equals 3y, and then I divide by 3. So y equals x minus 2 over 3, and therefore f minus 1 of x is x minus 2 over 3. It's just the inverse. So I know that this is equal to 32. So x minus 2 over 3 equals 32. So x minus 2 equals 32 times 3. No. Yes. 32 times 3 is 96. So x equals 98. Hold on. No, I'm really sorry. I'm very tired. Okay, so ignore what I just said. This part is fine. I then know that f of minus 1, 32, is equal to g of 2. So what's g of 2? G of 2 is when x is 2, so 2a plus b. And then f of minus 1, 32, I substitute 32 into x. So that would be 32 take 2 over 3, which is 30 over 3, which is 10. 2 more questions and then I can just, I don't know. Okay, so that's 10. So 10 must equal 2a plus b. Okay, so lots of work, lots of confusion maybe. It is a tricky question, but I want to show you how it's possible. So we just do it step by step. And then what have I got? I've ended up with 2 equations, okay? 2 equations that have the same variables. So what do we call those? We call those simultaneous equations. So let's line them up. I know that 5a plus b equals 28. And I know that 2a plus b equals 10. With simultaneous equations, what I want to do is eliminate one of the variables. So I can see that b would nicely be eliminated by subtracting. So I subtract the equations. 5a take 2a is 3a. 28 take 10 is 18. So if 3a is 18, a must be 6. And if a is 6, I just substitute that in. So let's substitute it into that. If a is 6, 12 plus b equals 10. So b must equal 10, take away 12, which is minus 2. So b is minus 2. So I know I'm going quite fast through this. It takes so long to put this together and there'll be no time for you to actually watch it but if this doesn't make sense, I can re-explain it in a separate video, so just let me know. Okay, so here I've got some simultaneous equations, but they are not your normal simultaneous equations. They are quadratic or non-linear simultaneous equations. So what you want to do here is essentially you're going to have one, most likely, you're going to have one equation that is linear. And what you want to do is rearrange it so that it's either equal to x or y. I think the easiest thing to do is to just say x equals 4 plus 2y, or x equals 2y plus 4. And then, so step 1, rearrange the linear. And step 2, once you've done this, literally just substitute into the quadratic. So I know that x is this, so I'm going to substitute that into the quadratic. So I'll be left with 2 lots of 2y plus 4 squared plus 8y squared equals 20. Now be careful here because 2 is being times by this, but BIDMAS applies, so I need to square this first. So let's do that. 2y plus 4 squared. And then I've got plus 8y squared equals 20. We'll deal with that later. So 2 times by 2y times 2y is 4y squared. 2y times 4 is 8y plus 16. So all of this is being times by 2. Then I add on 8y squared and it equals 20. So let's just double it. So that would be 8y squared plus, that would become 16y. So times by 2 is 32y plus 20. Okay, so I've expanded this. Then I add on 8y squared and it equals 20. So we're going to need a little bit more space here. So now I can simplify. So 8y squared plus 8y squared equals 16y squared. 32y doesn't have anything to simplify with. And then 20 minus 20 oh, that's 16, not 20, that's why. 32. I was thinking something was wrong. Okay, so 32 take 20 is 12. Because, and the reason I've done this, I've just moved that from both sides because in order to solve a quadratic, you need to make it equal to 0. So now I've got this, and because it's equal to 0, what I can do is I can manipulate it a bit. So I can divide everything by 2. So that would be 8y squared plus 16y plus 6 equals 0. And I could divide it by 2 again. 4y squared plus 8y plus 3 equals 0. And then I have a quadratic, which I can factorize. So you could use a quadratic formula, or you could just use this little thing where you know that If it was 4y squared, the only factors of 3 would be 3 times 1. 4 take 3. So that wouldn't work. So you know that it would have to be 2y squared. If you like the quadratic formula, just do that. I just prefer this because, I don't know. So what do I have to do? I think to myself, what two numbers multiply to make 3? 3 and 1. So 3 and 1. And then how can they make 8? Well, positive 3. 2 times 3 is 6. So that would be 6y. I don't know why I put squared. That would be 6y, and 2y times 1 is 2y. So when you add them together, that makes 8y. So factorise, that would be 2y plus 3, 2y plus 1 equals 0. Again, you can just use the quadratic formula. That's absolutely fine. And then what I do is I just use one bracket at a time. So 2y plus, oh no. So it just decided to shut down and restart itself. So I lost my working. But thankfully I have a memory of, I don't know, a goldfish. I think I can remember. So that was, what did I say? 3 and 1. Yeah, so that would have been 6y, 2y, so that works. Okay, so 2y plus 3 and 2y plus 1 is one of my brackets. It equals 0. So I'm just going to treat them each one at a time. So 2y plus 1 equals 0, therefore 2y equals minus 1, therefore y equals minus a half. So one of my y values is minus a half. Oh, top tip. You're always going to get, well, generally, you're always going to get four solutions, 2 x values and 2 y values, because a quadratic and a linear, when they meet, there's 2 sets of coordinates, x, y, and x, y. So just bear that in mind. And then I'm going to do this bracket. So 2y plus 3 equals 0. So 2y equals minus 3 and y equals minus 3 over 2. Okay, so I've got those values. So let's just write them up here and get rid of all of this because I don't need it anymore. So my y value is minus a half and also minus 3 over 2. To work out my x value, all I need to do is substitute that y value into one of the equations. Now, the easiest one to do would be the linear equation. So it just makes your life easier. So we could rearrange it so that it was x equals 2y plus 4, just to make it easier to work with. So when y is a half, x is going to be 2 times by minus a half plus 4. So 2 times minus 0.5 is minus 1 plus 4 is 3. So if they wanted it as coordinates, you would write 3 minus a half, but they haven't said that. So you just say x is minus a half, y is minus a half, x is 3. And then if y is minus 3 over 2, x is going to be 2 times by minus 3 over 2 plus 4. And 2 times minus 1.5 plus 4 equals 1. So if it was coordinates, it would be 1 minus 3 over 2. But they haven't asked you for coordinates, and sometimes they take off marks if you write it as coordinates and they haven't asked you. So just make sure that you write it in a nice, clear way. So a nice, clear way of showing it would be when y is a half, x equals 3. When y is minus 3 over 2, x equals 1. That's just a nice way of showing the examiner you've worked it all out. And that's how we do that. Okay, so the grand finale. Now, if you've made it through this video, I don't even know how long it's going to be, but I think it's going to be pretty long. Can you just leave a comment? Because you deserve some kind of accolade for going through all of this. So let's do the last question. So here is a frustum of a cone. All a frustum means is literally like a cone or a pyramid or something, and it's had its top chopped off. So you're left with this kind of, where are you? Yeah, this kind of weird shape thing. Okay, that's all a frustum is. So here is a frustum of a cone. The diagram shows that the frustum is made by removing a cone with height 2.8 from a solid cone with a height of 5.4 and a base diameter of 8.1. So, step 1. I am going to need to use my formula for the volume of a cone, which is kindly given to me. And that is 1/3 times by pi r squared times by the height. So let's start with working out the volume of the large cone. Equals, okay, so what am I going to do? I'm going to do 1/3 times by pi times by 8.1 squared, because that is the, oh no, I'm not. See, this is where it's good to write out the formula. They want the radius, not the diameter. So 8.1 divided by 2 is 4.05. So 4.05 squared times by the height, and the height is going to be all of this. So 2.8 plus 2.8 is 5.6. Okay, so that is going to tell me the volume of the large cone. So let's just type that into a calculator. 1/3 times by pi times by 4.05 squared times by 5.6 equals 96.1892837 centimeters cubed. Now we need to work out the volume of the small cone. So there's a few ways we can do this. They are going to be similar shapes because they are literally made of the same thing. So you can either do it by working out the linear scale factor, or you can use the volume scale factor when you've got similar solids. I don't know which would be easier. So, oh no, don't delete. Why does it do that? Okay, so essentially you've got this cone and this large cone, and you know that they are similar, so you know that they have a scale factor. So the height of the large cone is 5.6, the height of the small cone is 2.8. So therefore, the linear scale factor is, how do you get from the small cone to the large cone? You just times by 2. So therefore, to get from the large cone to the small cone, you divide by 2. And if the radius of the large cone is 8.1, the radius of the small cone is going to be half of that. I'm going to have to divide by 2. So let's just write that out there. So to remember, so diameter. So diameter of small cone is going to be 8.1 divided by 2, which is 4.05. And I need to know the radius, so I'm going to have to divide that by 2 again. So that is 2.025. So to work out the volume of the small cone, I'm going to do 1/3 times by pi times by 2.025 squared times by the height, which is 2.8. So 1/3 times by pi times by 2.025 squared times by 2.8 is 12.023666048. So a lot of work for just the first part of the question. Now I need to work out the volume of the frustum, and to work out the frustum, you literally do large cone, take small cone. So that's going to be 96.189, take 12.02. So 96.1892837, take away answer equals, so volume of frustum equals 84.16562339. Right, Excellent. So I know that that is the volume of my frustum. I then am told that the frustum is joined to a solid hemisphere. So this is the hemisphere, it's half of a sphere, which has the same diameter to form a solid. So it's literally got the same little circle as its base, and they smush it together and it forms this nice strange shape. Okay, so we're talking about density here. So I'm going to need to work out what the volume of this hemisphere is first. So the volume of a sphere is 4/3 times pi times r cubed, but I want to half it, so I either divide it by 2 or I times it by a half. So what's the radius? Once again, that's 8.1 divided by 2 is 4.05. So I'm going to do 4/3 times by pi times by, did I say 4.05? Yep, 4.05 cubed equals, divided by 2 equals 139.1309285. So that's the volume of the hemisphere. So because I'm talking about density, and I've got two different materials that have different densities, I am going to need to do some working out. So it really helps actually to do a two-way table to just gather all of this information. So you've got your density, mass, and then volume. Let's make this a bit bigger. Okay. Why is this failing? Okay, and then you've got frustum and hemisphere. Call you Hemi. So now let's put all of the information that we have. The volume I have worked out of the frustum is 84.165. The hemisphere is 139.13. I've got the full values here. Mass, I don't know, but the density I've been told, so frustum has a density of 3.2 grams per centimetre cubed, and hemisphere has 6.8 grams per centimetre cubed. So all that is left is to work out the mass, and I need to know the mass because to work out the average density I need the total mass divided by the total volume. This is why this is a little bit of a nasty question. So what's the formula for density? Well, density is mass over volume. So therefore, to work out mass, I just do density times volume. So I still have 139 saved in my calculator, so I'm just going to times that by 6.8. Whoa. Okay, so that's a mass of 946.09. All these numbers. So mass of Hemi is 946.0903135. And then I've got 84.165,62339 times by 3.2, which is 200. Let's write it here. Mass of frust, I'll call you Frosty because I think I'm slightly unhinging. Okay, 269.329915. Right, so we've got the mass. So let's add the two together. So plus 946.09 equals, right, so the total mass, don't do that. Okay, total mass is 1,215.419991. The total volume is 84.165,62339 plus 139.1309285, which equals 223.29655519. How do you work out density? Density is mass over volume. So I'm just going to do 1215.41 9991 divided by answer equals 5.44307551. They haven't said what they want it to, but normally it's 3 significant figures. So we could say the density equals 5.44 grams per centimetre cubed. And there we go. That is the final question. Hopefully some of this has been helpful, and I know it's not long until your exam, so hopefully this is out in time. So I just wanted to say thank you so much for watching. I'm not feeling my best, so there might be a few mistakes in there. Hopefully there aren't, but if there are, just flag them and I'll correct them in the comments so that other people don't get confused. Fingers crossed there aren't too many. And yes, thank you for thank you for watching. And just to finish it off, this is in honour and memory of Shadow, who just meant so much to me. So I hope that this video has made him proud.